Heather Facette works out at Grasslands National Park. Heather moved to Valerie to track snakes in Grasslands National Park following her graduation from the University of Regina with a BSc in environmental biology. The next few years, she worked for organizations like the Nature Conservancy of Canada, the Calgary Zoo Centre for Conservation Research, and the University of Alberta as a research technician before landing a permanent position with Parks Canada in 2013. Since then, she has worked on a variety of different projects involving the monitoring and managing of species at risk before taking on a leadership role within the restoration program. For the last few years, she has been seeding native prairie and trying to reduce non-native invasive plants at various locations within the park. Heather currently lives on a farm east of Valerie where her and her husband grow cereal crops and raise Black Angus cattle. So let's welcome Heather.
Hello, everyone, and thank you, Chet. I didn't realize my bio was so long, but thanks for covering that for me. I have a PowerPoint that I'll try to share, but interrupt me if it's too slow because I have a backup PDF as well. So we'll see how this works. How do I hide this now? All right, can somebody confirm that you could see my screen?
You're good to go.
Excellent. Yeah, so thanks again for having me here to talk about the vegetation management program at Grasslands National Park, and specifically the work that I've been doing over the last few years, which has been basically building native prairie where it didn't currently exist. So before I get started, I wanted to acknowledge that Grasslands National Park is part of Treaty 4 territory and homeland to the Métis. For centuries, these prairies were home to Indigenous groups that linked their lives to the migration of the buffalo, including the Atsina, Nakota, Nahiawak, Siksika, Dakota, Lakota, and the Métis. I want to acknowledge the history of Parks Canada's management, which has followed a Western philosophy of conservation, and the ongoing need to continue the transition towards shared governance that reflects the diversity seen across the country and truly inspires local communities. As I talk about restoring native prairie, I want to highlight that although the restoration techniques we have applied within these boundaries are healing some scars on the landscape, work still needs to be done to build relationships between people and the land, to continue to grow in its appreciation and come together for its protection. All right, so a bit of overview. I'm going to just cover Grasslands National Park so everybody knows where and what I'm talking about. I'm covering the overall vegetation management program and how our large field restoration fits into that big picture. I'll be covering some drivers of the program, and then of course the process of how we go about building native prairie where it didn't exist before. And specifically, we have some projects that are creating species at risk habitat. So I'll go through some of those projects as well. So Grasslands National Park is in Southwest Saskatchewan. It's one of only 2 national parks in Saskatchewan. And it's the only one in all of Canada that was formed just for the protection of mixed grass prairie. We have a proposed boundary, and since the 80s, land has been purchased to try to complete that boundary. Currently, the West Block is almost entirely purchased and owned and managed by Parks Canada. The East Block has a lot more private and provincial lease land, so there's a lot of collaborations there with our neighbors. Yeah, lots of good collaborations. So currently we have about 326 sections of land, which you can imagine seems like a huge portion of land to actually manage, which it is. But when we think about species at risk, habitat, and their ranges, it can seem like kind of just a little blip over the entire Great Plains. We're also designated as a dark sky preserve. And there was talks at one point to have us designated as one of the last quiet places. So it's a pretty cool place if you haven't been here before. Definitely come check it out. So fire is one of the big components of our vegetation management in the park. We recognize that fire has a lot of value for changing the vegetation on the landscape. You can have an impact at a really large scale. You can see in that middle picture, this is kind of a transition between an area that was burnt and not burnt. In the foreground on the left-hand side, you can tell that it hasn't been burnt, and on the right-hand side of the photo, it's a lot greener, it's more lush. There's a lot of American vetch coming out. There is more diversity, right? So that's that transition. You can compare kind of what fire can do to the vegetation community. And that photo on the top right-hand side there, that's a valley bottom habitat in the Frenchman Valley. And that was about a few weeks after a wildfire went through, and there was just a huge amount of wildflowers. It was mind-blowing. All of these photos are actually wildfires, which is not at all how we want to put fire on the landscape. We want to do it very intentionally, managing our risk, making sure we're protecting sensitive areas, protecting our infrastructure, and of course, protecting our neighboring lands. So fire is a very useful tool in an area where grazing is not taking place, but we do have a huge grazing program. At one point in our history, Grasslands National Park was not grazed. This was partially due to some of the views of how the land should be managed, but there is also some legislation that was restricting us from doing that. The Canadian national parks, there's no permission to graze domestic livestock within the boundaries. So Grasslands National Park had to actually go about having that changed. So with permission by the superintendent, we were allowed to now graze cattle within the park boundary. In 2006, we reintroduced the bison herd and have been managing that between about 300 and 500 head. And that land mass basically covers a third of the west block of the park. Everywhere else is grazed by cattle, either through formal partnerships or licenses. And currently we're starting a big project in the west block. That's a grass banking project, hoping to have some big conservation gains that way. So these are some pretty scary pictures, but these are the weed issues that we do deal with inside the park. We have leafy spurge that we've been managing for the last 12 years. Common burdock along the Frenchman River has been something we're focused on, I think the last 5 years. And then Japanese and downy brome has become more prevalent in the park and is taking a lot of our resources to do a lot of hand picking and spraying and monitoring. Yeah, so just so people know, the challenges definitely don't stop at the park with the invasive plants. So the work I've been working on for the last 3-ish years has been this large field revegetation program, which I would basically summarize as taking an area that doesn't have any wildlife value and trying to create something that is resilient to non-native plant invasion, is diverse in its composition, as well as the insect communities and the wildlife using the area, and basically reflects similarly what you would find in undisturbed native prairie. You can see here a couple photos. These are cultivated fields that were reseeded. The one on the left was 2014, and the photo taken only 3 years later. We already had some good plant establishment. That, of course, was because we had such a great precipitation year in 2015. The photo on the right was seeded in 2001, so almost 20 years later. It's looking pretty fantastic. There's a lot more diversity in there, and it's encouraging to see species that we haven't seeded show up in the field. So we were seeing juniper and rose bushes and lots of moss and lichen. The potential for us to do this type of work is enormous. So we have seeded our cultivated fields, but there's a lot of areas that were seeded to crested wheatgrass. So they have a history of cultivation. We also have areas that are being invaded by crested wheatgrass and smooth brome. And we also have the entire Frenchman River that has a bunch of hay fields that have potential for restoration as well. So there's multiple back-to-back careers if that's where we were going. I wanted to talk a bit about the drivers of our restoration program. So in 2010, the park management plan basically dedicated us to revegetating the cultivated fields within the boundaries. And we did meet that target in 2014. The next document that comes into play is the Grasslands National Park Multi-Species Action Plan. And it talks specifically about creating habitat for priority species. In this case, it's the greater sage grouse, black-tailed prairie dogs, and greater shorthorn lizards. And we do have a couple projects that fit into this guiding document, and I'll go through those in a bit. And then 2020, we drafted another park management plan. And I was very happy to see that we have more restoration in that document, focusing us on converting areas dominated by agricultural species back to native prairie. I like how they used various tools so that, of course, could incorporate some strategic fire or grazing plans and then revegetation. I put this question mark in here to remind me to talk about how we actually do this. So the restoration projects that we've done is not actually a part of our day-to-day operation. Parks Canada has a pot of gold, essentially, that we can apply for extra funding to complete these projects. I think the silver lining of us having so many species at risk in the park is that we're able to make a pretty compelling case and get funding for these projects. So again, the first kind of projects that we were tackling were these reseeding of cultivated fields. And that started way back in the late 90s, where they were doing some trials to figure out how best to do this. And then our last field was seeded in 2019. That last field was a part of a land deal. So that's why the dates don't necessarily line up from what I was talking about before. So anyways, how we would do this was we would keep the land under cultivation until the year before we're ready to seed. And that would be done through either license of occupation or renting the land out to a farmer in the area. That was to keep the weeds under control. The year that we're planning to seed, first thing in the spring, we'll spray with glyphosate, again, to control the weeds. And then we pull behind it our 10-foot broadcast seeder, the loose tine harrow, and the land roller. And so the loose tine harrow really incorporates the seed into the soil surface, and then we pack the ground behind it. I forgot to mention, actually, we run a heavy harrow over the field first, and that actually loosens the hard packed ground. And then we follow behind with this convoy. We put together our own seed mixes. I'll get into that in the next slide. But you can see, again, this 2014 field, only 3 years later, was already starting to look pretty good. It seems like initially in the first few years, it did quite well. And then we've been seeing really dry years. So it's not changed very much. We hope that over time, natural processes can take hold. We want to get grazing into these areas, either do prescribed fires or some interseeding just to increase diversity. We also talk a lot about how to get moss and lichen back into these fields more intentionally. Yeah, so far we've covered over 7 quarter sections of upland grasslands, and we've seen varying degrees of success. Even fields that were seeded the exact same way over multiple years look quite different. So I think the environmental conditions play a huge role in how they actually establish. So a bit about our seed mixes. For the cultivated fields, we use the most common 7 species of grasses, and the majority of our mix has been grasses. We do add handfuls of forb seeds just to increase diversity. And our rate over the years has been quite low. I think this was to compensate for the fact we are quite dry, but also to not be wasteful in terms of the seed, to making sure that we could have seed available to do more projects and have more of an impact over the landscape. We are looking into increasing the seeding rate just because we want to speed up establishment. So where we get our seed from, we do a lot of collection inside the park. We do a lot of seed cleaning, and we have a huge storage facility. Sometimes it's hard to get the quantity of grass seeds that we need, so we do purchase on the open market. We have really high standard. We're looking for stuff that's wild collected, hasn't had any genetic selection, which can be hard to find, but we have to also consider that balance of getting these projects completed. We want them to be successful, but we also want it to be very applicable to the region. We want that, we want them to be resilient to the conditions that they're going to find here. So we've also set up multiplication contracts where we collect seed inside the park and send it to people to grow out for us, and then we're able to buy the seed back. And we find that that's really helpful in making sure that we have the quality of seed that we're looking for. We're maintaining those local genetics, and we basically have a source for all these projects over the years. And of course, testing is really important. Whether it's being purchased or whether we're collecting ourselves, we're always testing it to make sure that the quality is there, and that, of course, we need that to calculate our seed mix and figure out what the purity and germination will be. So the cultivated fields, we do find, like I said, it depends on the year, how well they've established. These photos were of a field that was seeded in 2010. The photo was taken in 2021. It was a drought year, but you can see that there is native plants. There's a lot of sagebrush in this field. I'd say overall it was quite successful. And we're also seeing important things move in, like moss and lichen and native songbirds using these fields for the breeding season. If we look at the results in more detail, I can't see my slide. There we go. Yeah, so we did some monitoring in 2020 and 2021 just to see how all these fields compare to what our targets are. And we got these targets basically from what we figure the reference plant community would be for a lone ecosite. So overall, the fields that we monitored in the last 2 years, the average cover of bare ground was less than 10%, which is encouraging. Our litter cover was quite high, and I think that's because some of our fields aren't being grazed or burned, so there's a lot of accumulation. Again, that moss and lichen is coming in. It is very low compared to what you would find in a reference plant community in such a dry location such as this. Our grass and forb cover is encouraging. Again, these were really dry years, so I think that might have been underestimated. And then an important thing we want to monitor is those non-native species. Typically, early on in our restoration project, we have a lot of broadleaf annual weeds that come in, which aren't a concern. What we're really concerned about is those invasive perennial grasses like crested wheatgrass, because it's hard to control in a revegetation scenario. All right, so this is getting into one of our wildlife or species at risk habitat creation projects. So you can see on the right-hand side in this map, the green polygon is the black-tailed prairie dog colony in 2015, which was when we started this project. The yellow lined area is the extent of our restoration area. We haven't actually reseeded all of this, but that's kind of what is disturbed and has potential to be converted to native plants. On the left-hand side, that photo is what the area looked like, right? So it's really tall and dense, and it's not an area that prairie dogs would actively move into. So this colony was really restricted on the interior with the vegetation. They can't move into it because they can't keep up with clipping and keeping it open and bare and that line of sight that they're looking for. And on the outside of the colony, they're in kind of a bowl. So the topography changes drastically and they don't easily build colony up steep slopes. So this was a great location to focus in on a habitat creation project for black-tailed prairie dogs. Essentially what we were going for was a native plant community and provide the potential there for prairie dogs to move into it. And you can see in the map, I'll just point out that the black hash outline, that was actually what the colony looked like this past fall. You could see that prairie dogs are expanding into this area. They definitely did not move in because of our restoration efforts. It was one of the years that because it's a drought, they are expanding, and they were expanding everywhere in the park. However, they were able to move into the area because this vegetation wasn't restricting them. So the sell here is that we're trying to keep them inside the park in this area instead of having them move outside the park or try to find another colony that's further away. Some of the work we did to prepare the site for restoration was in 2015, we mowed. In 2016, we sprayed and we burnt. We seeded a third of the area in 2017, and then another third in 2018. We ended up seeding in 2 drought years. So in 2019, we weren't seeing good establishment. In 2020, we went out and mowed, but we still weren't seeing a whole lot come up. By 2021, we decided we were going to reseed that area. So this fall we went out and we used that heavy harrow. We did 2 passes to loosen the topsoil. And then we pulled behind it our broadcast seeder and roller, and you can see the difference between the seeded and not seeded area. We are really incorporating that seed into the soil. So another wildlife habitat creation project that we just started recently is converting this old hayfield into a sagebrush community. We're calling it a pilot project because there is a lot of potential to do this across the entire Frenchman River. There's a lot of hayfields, and we could potentially be doing this for 150 years, basically. So what we're going to be doing is trying to grow a sagebrush community. We're looking for that over 15% sagebrush cover. We want over 10% forb cover, and we want the rest to be native. How we're preparing the site is we baled in 2020. This is an area within the bison holding area, so it doesn't get actively hayed on a regular basis. The vegetation was really built up. It burnt in 2013 when the huge wildfire went through, but that was about it. So we needed to start clearing the area and preparing the site. And in the fall, we also did a glyphosate application in 2020 and 2021. We're seeing that the biggest weed issue in this area is Canada thistle. So we want to make sure that we're getting out there in the fall to help control that species. And kind of in line with what we've been doing elsewhere, we do depend on cultivation to control those non-native species. So we contracted this work out for the next 4 years to have somebody come and grow a crop, provide that competition to the invasive plants, and then help spray as well. Our plan is to seed in 2025. And the unique thing about this project, I think, would be the seed mix. So we're going to put out way more forb species than we've done in any of our other projects. And our seeding rate is quite a bit higher. Hopefully there'll be lots of moisture at this site, having it be a low area near the Frenchman River. We'll see how it goes. So as we move into the future, we're definitely looking for ways to increase our establishment rate. We're doing that, for example, by doing fall seeding and increasing our seeding rate. We want to be initiating grazing in those fields that have been excluded. I think it's to the point now where they're not doing themselves any favors. We need to have those natural processes restored to the area. And we're talking a lot about restoring biocrusts and doing a lot of research on what that looks like and how we could get that done. We definitely want to support research on restoration. We are a land management organization. We don't do a lot of our own research. So having partnerships or supporting research that can guide our decision making is really important. And we want to keep monitoring our past restoration fields and managing them so that they're not constantly at risk of further invasion. And I put this photo up here. This is one of our old restoration fields. It was seeded in 2003. And from the road, it kind of looks dungy. it doesn't look to be successful, right? And so we went out and did monitoring, and when you got down on your hands and knees, we could see how much native plants was actually growing underneath the alfalfa and the sweet clover. So one idea that we had was that we would take out this wick weeder, we would put a selective herbicide in it and see if we can kill back some of that alfalfa and sweet clover. And this is last year was the first year of a 3-year trial to see how that actually works. This is definitely a collaborative effort. Like I said, I've been doing this the last 3 years, but the program's been running for 25. So I can't even go through a list of all the people that have participated and contributed, but I think the program is pretty well established, and there was a lot to build on when I joined. And I don't know, I think that there's a lot of potential yet, so we'll see how it goes. And just coming back to the fact that Grasslands National Park is a park, and I encourage you to come visit. The last few years, I think we surpassed 20,000 visitors, and the more people that come and visit, the more support that is provided to park sites. So if you do come, I encourage you to share your experience on social media, tell people about your experience, and encourage them to come as well, and ask about restoration and why we aren't doing more, and maybe they'll support more restoration work. I think we have lots of time for questions.
We do, yeah. If anybody has questions, either put them in the chat or in the Q&A. All right. Okay, Doug says, can we assume that the native plants that appeared years after the initial seeding, for example, the juniper, came from seeds that were dormant in the soil?
I would say I don't really know, but it could be that it was already there, or it could be transported by wildlife, right? So I wouldn't be able to say for sure, but I think there's a couple ways that they can be transported to that site.
Okay, Branimir says, thank you for the presentation. I've been visiting Grasslands National Park for over 20 years. Over the last 10 years, I noticed the visible increase in the presence of crested wheatgrass and sweet clover in the Frenchman River Valley, especially along the Eco Tour Road. Do you think this could be caused by increased vehicle traffic and or lack of grazing management?
I think grazing is a part of it, right? Because it's in like the areas where we have huge issues with crested wheatgrass is actually in the bison area. The bison don't select crested wheatgrass. They'll eat the native before the crested wheatgrass, which is not helping in that management, which is why I think we need to do maybe some strategic mowing and prescribed fires to help knock it back a bit. But I would also agree that it is, yeah, invading into new areas and should be addressed. And I think moving forward as our vegetation management program grows, I think that's going to be a part of it, is really mapping crested wheatgrass and where it's expanding into native prairie, and taking those areas that are pristine and keeping them from having that crested wheatgrass move in. And then where we have huge patches of, you know, monocultures of crested wheatgrass, those might be targeted for a complete overhaul of restoration.
Andrew says, I think restoration is a growing topic in the prairies, no pun intended, with lots of small and large scale restoration projects going on. Does Parks have any resource documents to share with other practitioners, such as lessons learned?
I think we definitely do. We don't have anything that's publicly available, but if you reached out to Parks staff, we would definitely be willing to talk about our experience. We do have some reports that may or may not be valuable, but I think definitely having those conversations. I'm also really interested in having more tours of our restoration sites, whether that's with stakeholders and neighbors, or whether we do that with the public and visitors. So I think there's potential there, especially now that we're seeing some of the fields are quite successful. It's a story that we want to share. So we don't have any documents basically that are available to the public, but we're definitely interested in facilitating whatever support we can to have more restoration take place on the prairies.
All right. Yeah, Heather, you and I might have to talk because I know an organization that would love to do field tours this summer. So maybe we can put something together here.
I think that that would be fantastic.
Yeah, we haven't had field tours for the last 2 years because of the pandemic, but yeah, I think there's plenty of room to social distance if we need to out in Grasslands. Donna says, great presentation, so informative. Beckett says, super cool presentation. Is the 2025 restoration site by the Frenchman River on a historical floodplain? If so, could it be flooded with a beaver dam analog to increase site moisture for establishment?
Well, it is adjacent to the Frenchman River, and I did a lot of thinking about how the hydrology of that site has changed over time, right? Because my whole idea of restoring an area was to take it back in time before there was any sort of disturbance. And a lot of good conversations took place about, you know, what has changed over time in the hydrology. And for sure, the Frenchman River has changed. There's two upstream, well, there's more than two upstream dams where they're controlling the water flow. So I think that has had an impact as well. There's potential to flood it. I just don't know that we'll have the guaranteed water levels when we need it. So that's not really something that we're targeting. And this site I found was a balance of hay fields because there was a lot of hay fields that are just 100% smooth brome. And to me, it's obvious that the flooding cycle would be greater or more frequent. Whereas this hay field that we're doing the pilot project on, there's a lot of crested wheatgrass in there, and there's a variation of topography where I think some areas of the field might flood more frequently than others. So it'll be interesting to see how our seed mix kind of fills all of those niches and what will come up in the end.
Anna says, do bison graze year round?
The bison do graze year round, yes.
Okay. Are there any more questions? Oh, yep, there sure are. Can you also discuss about the longer term management activities on the restored sites? You mentioned that grazing hasn't been implemented in many of the restored areas. Do the areas with excess litter and lack of natural disturbance, fire or grazing, start to lose some of the initial diversity? How many years after restoration are you waiting to begin grazing or disturbance regimes?
Yeah, so the timeline is a tricky one because our fields are establishing at such unpredictable rates. So the fields that haven't been grazed are in one specific location, and they've been seeded between 2005 and 2014. And it took a long time for them to even have plant cover. So we just went out this past year, and walking around, you can tell that the litter is starting to build up, and we do want to graze it, but we don't want to set ourselves back either. So we want to have a really light grazing plan. And we also are considering having some grazing exclusion cages just to really showcase how grazing can change the vegetation that's growing there. Was that the whole question, or was there more to it, Jet?
I think that's it.
Okay.
Yeah.
Feel free to add a follow-up.
Dorothy says, why would a place that is publicly owned, like a national park, not make its operational knowledge public? What has been done and what worked? Oh, for example, what has been done and what worked? Seems counterproductive and non-public.
Yeah, like the information is definitely available to the public. I'm just thinking like we don't have documents that we are posting on those lessons learned. We do share, you know, through presentations, through social media. We're trying to share the information. I guess there's just hasn't been a platform for us to just put our reports up there for review. it's not a secret by any means. We do want to share this information, but I just don't know how that would be facilitated in a way that's actually helpful to people. So at this point, I would just say reach out to the park. We're trying to share the information and as openly as we can and as easily as we can, but I just don't know where that information should be put to make it that easy for people.
I'll put the offer out there. We do have a restoration revegetation webpage on our website. I know, government documents on a non-government website might be a tricky thing, but if we can make it work, we're certainly open to posting whatever documents you would like to share, if they can be made available in that way.
Yeah. And I think maybe this is just a good point, hearing these questions, maybe this is an opportunity to maybe wrap up our restoration of cultivated fields by having a document that is fully complete and can be posted as kind of like, this is our 20 years of lessons learned. I think just when I'm looking at documents, they're always kind of in a state of adaptation. We're always updating them and reviewing them. So maybe there is an opportunity there just to put something more formalized out there to the world, but I would have to find out a way and some time to work on that.
Any more questions? We have a few minutes left. I think we're caught up on questions now. Well, how long does it take to get Selaginella densa established? Good question.
Very good question. And so we do have some in our fields, even some of the younger fields, they're in there. So we don't really have a timeline. I think there's a really good opportunity to do some real research. We talked about this quite a few years ago before I even started. There was somebody that was interested in doing translocation research project to see how fast or how well it actually establishes in a new site and how fast the cover expands. So there's definitely some research opportunities there because we don't have the answers. And I think we're just at the early stages of figuring out how we would do restoration of those species on a large scale and what species we'd be focusing on.
Yeah, great question. I know some of you may remember Darcy Henderson. He was the grassland ecologist with Environment and Climate Change Canada in Saskatoon. He was thinking about this maybe 10 years ago because they had restoration projects out at Last Mountain Lake National Wildlife Area that they were trying to get those kinds of species and biocrusts in general established. I mean, there's no commercial source for any of that. There's no protocol. So I'm really glad that Grasslands National Park is pursuing that avenue. It's going to be an interesting next, decade or so on that front. Yeah, I think it's really going to evolve. So I'm excited to see that. Any questions? Any more questions? We have maybe time for one more question. Nope. Going once, going twice. All right. Thank you very much, Heather. That was really fascinating. Great, great visuals there, and a lot of success to see even those new fields, but especially that one that is almost 20 years old. I doubt the average visitor, if they were to stumble on that, would know that is even restored. And I think that's ultimately what you're going for, and to have the songbirds nesting in there and other wildlife species using those areas as if they had always existed is the objective. So I think that was fantastic. I was pleasantly surprised by the amount of lichen species and club mosses and things you were able to get in there, and by the almost absence of invasive species, which is just the bane of every time I do something restoration wise, that's always top of mind is, what kind of weeds and how many am I going to have to contend with, and how do I, plan for that, mitigate that? And those statistics were amazing. So that's great, and we wish you all the success. And one more question while I was going on: do the bison create wallows?
They definitely do. That is another great disturbance that they've been putting on the landscape. And you'll see when you go through wallows, there are, unique plants growing there, and they're adding just that little bit of mosaic to the landscape.
And correct me if I'm wrong, Heather, but I heard Wes Olson, he used to work out at the park. I think he even mentioned that bison had opened up old wallows, like from the original bison that were on the land. Is that correct?
I would not really know anything about that, but I wouldn't be surprised. And yeah, Wes definitely knows his bison. So if that's what he was saying, I would believe him.
Yeah, I seem to remember him saying that, they were all, revegetated, but it was there. You could tell it was likely an old wallow, and some of the first bison that were released, had come back into those same areas and opened up some of those same wallows,
Very cool.
which I thought was fascinating. Yeah, they have no memory of that. They just picked the same spots that their ancestors picked.
Picked it for a reason, I guess.
Yeah. All right. Well, I'd like to thank you again. Great presentation. And who knows, maybe we'll all meet again out this summer on some of those sites and learn more.
Sounds good to me. Thanks again, everybody.
All right. Our next speaker is Katie Suek. Let me just do a short introduction on her. Katie Suek was born and raised in the rolling prairie of southeast Saskatchewan. She's a mom of 3 busy boys and is formally trained as a human environment specialist with a focus on community engagement and environmental assessment. In her spare time, Katie and her husband Aaron own and operate the Restoring 71 project, a prairie habitat conservation initiative. So I will turn it over to her.
Awesome. Thanks, Chet. Can you hear me okay? This is computer. Perfect. It was not a great day to change computers, but we're doing it. Okay, I will share my screen. Are you able to see that all right?
Yep.
Perfect. Okay, so good morning, everybody. Thanks so much for having me here today. Speaking to you today from the Restoring 71 project site, which is located on Treaty 6 territory and homeland of the Métis near Saskatoon. I was really excited when the Native Plant Society asked me to present to you today, and even more excited when I learned the theme of today's event, the United Nations Decade on Ecosystem Restoration. I've spoken at a lot of different events, but this is the first time I've had a chance to speak on this topic. So you're my guinea pigs. We'll see how it goes. All right. So to kick things off, the Restoring 71 project is a conservation and restoration project situated on private land, which is owned, funded, and managed by my husband, Aaron, and I. We purchased the land in 2014 and started taking steps to restore it in around 2017. So what does Restoring 71 have to do with privately protected areas? And what does all of this have to do with the UN Decade on Ecosystem Restoration? That's what we're going to talk about today. First of all, I wanted to note that all of the photos that are in this presentation were taken either by myself or my husband, Aaron, right here at Restoring 71. So what you're seeing is what we see out in our backyard every day. Okay, so up on the screen right now are the objectives of the decade. So it's the first 2 that we're going to really focus on today. And those are showcasing successful government-led and private initiatives to halt ecosystem degradation, restore those ecosystems that have already been degraded, and enhance knowledge exchange on what works and why, and how to implement restoration at scale. So the International Union for the Conservation of Nature, the IUCN, has adopted and is helping to drive the UN Decade on Ecosystem Restoration by providing tools and urging people to explore nature-based solutions. At the same time, they're also driving several other concurrent and interconnected initiatives that contribute in one way or another to ecosystem restoration. And one of these initiatives is raising awareness about the need and benefits of private areas. So privately protected area is a clearly defined geographical space that's recognized, dedicated, and managed through legal or other effective means to achieve long-term conservation of nature associated with ecosystem services and cultural values. So according to the IUCN, privately protected areas are underrepresented in national protected area systems and underreported internationally, despite the fact that they're a rapidly growing element of the conservation estate. They also say that privately protected areas provide the opportunity for voluntary contributions to conservation, complementing the role of government agencies, Indigenous peoples, and communities in caring for nature. So the only private protected areas that are dedicated and managed through legal means, such as conservation easements, are formally recognized and counted. And while we're not formally recognized as a private protected area, we designed the Restoring 71 project to meet every other requirement so that when Canada is ready to get creative with their definition of legal or other effective means, we'll be ready to put Restoring 71 on the international map. Ambitious, I know. So what does this look like in practice? Well, step one is to establish a clearly defined geographical space. So the Restoring 71 natural area, which is what we call the land that we're restoring, is, you guessed it, 71 acres in size. When we bought the land 7 years ago, it was an annual cropland, an overgrown hayland, and a massive flooded wetland basin. It also had about 4 poplar stands, a chokecherry stand, and a splattering of willows around the wetland area. So the site's located in the arm of Vanscoy, which is about 10 kilometers west of Saskatoon, just to get your bearings. And this space is privately owned by our family. So before the site really started to revegetate, we mowed about 4 kilometers of trails, which are shown kind of on the map here as the dotted lines. So we mowed them across the site to provide access to kind of key habitat features. So the key habitat features that we work with and educate on are the watering hole, which is our big wetland area, the willows, which has its own kind of ecosystem going on there, the sea of grass, poplar bluff, the lowlands, which is the area that was flooded and so is in transition right now, and Hawk's Nest Bluff. And then in this little corner, I don't know if you can see my mouse, hopefully in this little corner on the left-hand bottom side here, that's actually a restored native grassland area. So it's predominantly native species. And we'll talk more about that later. Okay, so step 2, figure out how to recognize, dedicate, and manage the site for long-term conservation. So this is a longer step, obviously, but we do this through our 3 pillars. So conservation, restoration, and education. So focusing effort on activities related to each of these 3 pillars also helped us to address a couple of the objectives of the decade that I mentioned earlier. So that's the showcase private initiatives to halt ecosystem degradation and restore ecosystems that have been degraded, enhance knowledge exchange on what works and why, and how to implement restoration at scale. So over the next few slides, I'm going to share a bit about why we chose these pillars and the actions that we take related to each pillar and some of the impacts that those actions have made over the last 5 years. Before I dive into that fun stuff though, it's important to understand some of the constraints that landowners face when it comes to restoring or conserving their land. These considerations or constraints are really specific to our experience navigating in this space as a small-scale private landowners who don't profit from the land and have chosen not to enter conservation easements. We also, watching the previous presentation, I was so jealous of all the equipment you have access to. We do not have access to that level of equipment or storage space. So those are some additional considerations that we have when we're planning. But these considerations that are kind of overarching are, right now there's no legal or government facilitated way to restrict development or expropriation of private land. That's on our minds. There's no tax incentives or carbon offset options for people who don't profit from the land. Limited access to external funding, which is improving little bit by little bit. So I'm excited to see more of that opportunity. Limited people power. So for the most part, unless we have classrooms out, it's just Aaron and I that do the bulk of the work. And we work full time and have kids, so we're doing it on weekends and in evenings. and then limited examples to model after. And I'm going to talk more about that later. Okay, so conservation. So at Restoring 71, we halt ecosystem degradation by applying several conservation strategies. So to know what strategies are best to apply in your space, you have to have an idea of what it is that you're protecting. When we started this adventure, we had no idea how to identify plants or wildlife species, and we had no ideas what sort of habitats or conditions they need to persist here. So I'm an anthropologist and my husband's an engineer. We have no biology training, nothing like that. So from 2018 to 2020, we became quick studies. So we bought bird books and plant books and took lots of classes and tons of photos and did lots of research on our own. So one of the photos we took is this one right here. And so this is our family of loggerhead shrikes, and they've been nesting here for as long or longer than we've lived here. So that's at least 6 years. And in this photo, they are out for a hunting demonstration with their 2021 fledglings. So that was fun to see. So the more we learned and the more we got to know the land, the plants, the wildlife, and how they all interact with each other, the more we understood what systems were working well and which systems were actually degraded. And while we originally assumed that land that had been tilled, cropped, and hayed for nearly a century would be quite uniformly degraded, we quickly learned that we were wrong and that we underestimated Mother Nature. The land wasn't entirely degraded, it was just dormant in some spaces. And we'll talk more about that when we get to restoration pillar. But the way that we knew that there were functioning systems here worth protecting was by looking at our long list of species at risk that we've observed in the last 4 years alone, just using the site. So the 25 species that are listed here, 14 of them are regular visitors to the site, meaning they regularly rely on the habitat, either for migration rest stop, mating territory, or just a great place to raise their families. Having species at risk on your land creates an automatic layer of protection. And when you're a landowner who chooses not to enter a conservation easement or other legal means of protection, you need to find ways to protect your land that work within the legislation that's available to you. So examples of layers of protection. So the ones that we are trying to work within are the Species at Risk Act, Migratory Bird Convention Act, Heritage Property Act, and Environmental Assessment Act. And I'm just going to talk about the Species at Risk Act and Heritage Property Act today. Otherwise, I could talk for hours about this stuff. But so how did we figure out what layers of protection are available to us? This is where my day job comes in handy. So I am an environmental consultant. And at the time when we were starting Restoring 71, I was spending my days advising clients on what environmental studies, assessments, and permits they needed to be able to get the required approvals for their various projects. So to find out what surveys or permits you might need, Chet mentioned this earlier, we start with HabiSask. So it's an interactive mapping tool. On HabiSask, you can look up a quarter section of land, find out what historical species of conservation concern have been observed there and when they were last observed. And HabiSask also shows you lands that are considered heritage sensitive. When we browse through then on top of looking through HabiSask, we browse through a lot of other aerial imagery sources like Google Earth, Google Maps, and what we're looking for there is land use information. So presence of wetlands, other natural areas like native grasslands. And if we find evidence of habitat that could support species at risk, we flag it for field studies. And in this context, when I say we, I'm talking environmental consultants. So if we find evidence of habitat that could support it, we'll flag it for field studies and note that permits might be required or that activity restrictions might apply. Our best chance at protection at Restoring 71 is giving environmental consultants all of the clues that they need to identify us as a site that requires further screening or engagement. In practice, this means that when we see a species at risk, we report it along with pictures for proof, mostly through iNaturalist, which go when we click the Sask CDC project link, it goes right to Saskatchewan Conservation Data Center. And all confirmed observations are then eventually entered into HabiSask. So we also created a Google place for Restoring 71. So now it shows up just like a business on Google Maps. So that helps us because people, when they're looking, can see, oh, there's something there. Finally, we're really fortunate to have found a projectile point at Restoring 71. And so we shared that observation with the Heritage Conservation Branch, and now we're designated as a heritage site. So that will get flagged if there's ever a project that requires a heritage assessment in this area. So once in a while, I like to just hop onto Athabasca to feel reassured that our work is paying off. And I like to brag about how it is paying off. So I'm going to show you what we got here. So it's a bit blurry because it's just a screenshot, but if I was doing an environmental screening and I came across a big blob of dark green or dark red, like the area shown in blue here, then I would be looking a lot closer at that location to see why it's such an anomaly. And in this case, that anomaly in the blue circle is actually Restoring 71. So the final conservation strategy that we employ beyond kind of these layers of protection is really a blend of conservation and restoration, but it's invasive species management. So because the area is a former cropland and hayland, our battle with invasive species will be a long-term endeavor. But we're doing our best to manage invasive species on the site. And by doing so, we're protecting critical habitat features like our native grassland, shrublands, and poplar stands, and the riparian areas around the wetland, which seem to be the most challenging places to try and control native invasive species. That seems like a really great place to jump into our restoration efforts. Okay, so how do we restore degraded ecosystems at Restoring 71? We do it by applying both passive restoration techniques and active restoration techniques. Our primary goal with restoration is to restore soil health and nutrients that are needed for the growth of native plants, and then reintroducing native plants as needed where there aren't any emerging from the seed bank. So this photo was actually shared with us by the outdoor school classroom students after our big planting day last spring. They're planting native seedlings on site. And we can talk more about that partnership with outdoor school when we get to education. But first, let's talk about passive restoration. Passive restoration is essentially just limiting disturbance and letting Mother Nature do her thing. It's the let it grow method is what we call it. And at least at Restoring 71, this method has been incredibly successful. It's based on the belief that the native seed bank exists in the soil, and when conditions are right and they are good and ready, the seeds will germinate and the plants will grow. So as an example, this sneezeweed plant popped up in the riparian area of our wetland as the wetland was drying up due to the current drought conditions. And that was a couple of years ago. So it grew and bloomed for 2 summers and we haven't seen it since, which is sad because it's my favorite that's popped up. But we're hoping that there's still seed in the seed bank and it will pop up once we start getting wetter years again. Another example is this area that we call our native patch. So this is a small kind of half-acre corner of the property that was previously disturbed for crop and hayland until equipment became too large to get into the corners. So this little corner has self-restored itself over the last couple of decades and is now home to around 20 native grass and thorp species. Last summer, we earned our Pollinator paradise status from Wild About Saskatoon. So we have to showcase that. This photo was taken in the fall when the golden aster were really blooming. The power of the power of passive restoration is most noticeable, though, in the amount of tree growth that has occurred over the years. So obviously, you need to use your imagination a little bit here because there was not color aerial photos back in 1956. But you can see that in 1956, the north portion of the site was tilled and seeded to annual crop. We can tell that just because there is no variation in texture in the aerial photo. So to me, it looks like the south portion was either recently seeded at the time to hayland or was being used as pasture. And that's just judging from these kind of straight lines that we see. Those are very much human-made. In the north, so the north portion of the land has been continuously seeded to annual crop. We've got a whole pile of aerial imagery, but it's been continuously seeded to annual crop until the land switched ownership in around 2012 or 13. The south portion was seeded to crested wheatgrass and smooth brome in the late 90s, so down here. And these are still the dominant vegetation types in the open grassland area. So as you can see, the tree stands have been there for about 60 years, these kind of core tree stands, probably more than 60 years. But by limiting disturbance, they've expanded considerably. Most notably, though, is the riparian area growth around the wetland. The majority of the growth there is comprised of multiple species of willow, some poplar, and a few aspens and cottonwoods mixed in. When we forged the trails back in 2015, so you can see kind of the trails all through here, there were no trees that were mowed down at the time. So you can see just the sheer amount of growth that's taken place just in the last 4 years. We have later aerial imagery, but the drought has really taken a toll on some of the greenery levels. So this was the best photo that I had to show kind of impact. Now, we really struggled with trying to find a balance between trees and grassland. So to the east of us, the landscape's predominantly grassland, but immediately west of us is the quarry swale, which is predominantly forested. And so we decided that the current blend of trees and shrubs and grassland seemed to be working well for the 150 wildlife species that we've seen interacting with the site in the last 4 years. And luckily, the trails, which we keep mowed down, serve as a buffer to limit further spread of the willows, maintaining those grassland areas to be restored in the future. So that's passive restoration. Now on to active restoration. So this is the part of my slideshow where I started to get lazy. And instead of boring you with a bunch of text, I'm just going to invite you to enjoy some of my husband's photography for the rest of the slideshow while you listen to me ramble. So that's what we're doing now. Active restoration is the deliberate action that we take to restore degraded areas. This can look like prescribed burn, soil enrichment, mowing, grazing regimes, controlling invasive species, and of course, planting desirable species. For the last 4 years, we've been under fairly constant fire ban from April to October of every year due to the current drought conditions. And for this reason, we have not attempted a prescribed burn. Our land's not currently fenced, which makes livestock grazing a fairly costly effort. And because of the drought conditions, we've been really hesitant to put a lot of effort into seeding areas that will be hard to water. And so what have we done? Because that's a lot of complaining and not a lot of solution. But we do have solution. So the actions we've taken that work within our available time and budget, which take the drought and fire bans into consideration, are managing for invasive species, applying strategic mowing to put pressure on tame grasses and non-native species, and we've been seeding what we call restoration plots near the yard site where water is readily available. These restoration plots are situated in a way that will allow us to, plot by plot, create a native prairie pollinator corridor across the most degraded part of the site, which is that north portion which was previously used as annual cropland. These plots will also be used eventually to source seeds when we're ready to for bigger plantings in the tame grasslands. So they're small now, but they will help to make bigger impact in the future. We also try to work with opportunities that present themselves. So for example, in the fall of 2020, in response to a bunch of uncertainty about how in-person indoor school would look, we created an outdoor classroom space to provide an extra option for parents and teachers who wanted to incorporate fresh air learning into their curriculums. When we mowed this area down to build the classroom, we didn't anticipate that we would turn up so much soil because of the drought conditions. So we used this opportunity to add some native grass and flower seeds to the seed bank in this area. So far, we haven't seen anything emerge other than tame grass and thistle, but we'll keep mowing it down, keep pulling invasives, and hope that once we start to see some more wet conditions, that native plants will start emerging. While mowing definitely did not work as we had hoped in that outdoor classroom space, it has made a phenomenal difference in our efforts to expand our native patch. This is a picture of this. We have a lot of strawberries in the native patch, which I love. It's exciting every time to go back there. Okay, this is obviously not the most professional looking figure I have ever created, but it does the trick for this purpose. So in this area, in the bottom left, is our native patch. It's located in the southwesternmost corner of the site, and just above it is a strip that says fourth year. So this is actually our trail. It is not to scale, just bear with me. So this is our trail. So we've been mowing it probably 3 to 4 times a year to keep the trail maintained. And above that is a patch that says 2 years of disturbance. So this is actually a swath of tame grass that we mowed 2 years ago and haven't mowed since. And then this little rectangle right above it that says first year, we mowed that for the first time last spring. Beyond that, in this big area, it looks like it might have cut it off, is tame grasslands. So we call this our sea of grass, and it is comprised 100% of crested wheatgrass, smooth brome, and the odd alfalfa plant. There are no native species located in this area. So when we look at how it's kind of broken out, we've got 0 species in this tame grassland area. We have about 20 plus species that we've observed in the native patch. And I word it that way because I only started learning how to identify plants about 2 years ago. And so I am not a pro, and I have probably missed some. And I also note that we have new species appearing in the native patch every year. And so there's probably more than 20. I just haven't found them yet. So we say 20-ish. So in this 4th year, on our trail site where we're mowing it multiple times a year, 11 native species have started growing here. In the 2nd year of disturbance, where we mowed it once and we left it for 2 years, we have 8 native species currently growing in there. And then in this 1st year disturbance rectangle of ours, we have about 3 species growing already just last year, once we kind of put some pressure on the tame species. And so I think that shows that, you know, it's making a difference, the strategic mowing. I'm sure there's better ways to expand this native patch, but within kind of the tools we have available to us and the time and funding, I'm really pleased with the results so far. The trick is going to be figuring out how we can encourage it to become a self-sustaining system. Right now, it's working because we're applying strategic disturbance, but we're going to try and work towards figuring out a way that it can be self-sustaining and it won't be taken back over by those tame species once we stop applying strategic disturbance. There's always a million what ifs and what nexts with restoration. The final active restoration strategy I'll tell you about today is our eco-buffer. So with the help of the Outdoor School and Walter Murray Health 9 classes, we were able to complete our eco-buffer this year. For those unfamiliar, an eco-buffer is similar to a shelter belt, but more diverse and designed with attention to creating a layered canopy and choosing species with staggered lifespans. It just makes a more resilient and sustainable buffer. So they're also designed with a native forbs row, which was the main focus of our efforts last summer. So using a combination of seeds that we purchased from Blazing Star Seed Company and that were donated to us by the Native Plant Society, the outdoor school students spent the early spring of 2021 learning how to grow native plant seedlings indoors, and they had amazing success with this. So in June of 2021, they planted over 200 native plant seedlings that they grew themselves at school and planted into our eco-buffer. So this partnership with both classrooms from Walter Murray Collegiate in Saskatoon was made possible through the One School, One Farm Shelter Built project. So I want to give them a shout out. As I mentioned earlier, funding and time are some of our biggest constraints as landowners when it comes to advancing restoration projects. These partnerships can help make active restoration efforts realistic and achievable goals for us. We also had amazing success in the fall. I needed to report back to One School, One Farm on our success rates. And with our native seedling or our native forb seedling plantings, we achieved an 85% success rate with how we did it. So that seems like a great segue into the education pillar. So we enhance knowledge exchange on what works and how through applying actions under our education pillar. When we started Restoring 71, we recognized that our little patch of prairie was small, it lacked connectivity, and is a prairie in transition, not a pristine wetland, native grassland, or forest. In the grand scheme of agricultural and conservation value, it had neither going for it. When we started this adventure, we had no idea how to do it, no idea what resources were available to us, and no model or example in Canada that we could find to guide us as private landowners. So to be clear, I guess, we eventually found the Native Plant Society and a few other groups who had created amazing restoration resources that we absolutely use, but the conservation aspect was largely oblivious to us. We assumed, like many others who've approached us since, that in order to be taken seriously as a conservation or restoration effort, you needed to enter a conservation easement or other arrangement with the government or a conservation agency, et cetera. And to this day, people still ask us, where can I sign up? So we saw that both as an education gap and an opportunity to help address this gap. So as part of our education pillar, we committed back in the day, 5 years ago, to deliver presentations like this one today and created a social media presence. We share photos and videos and stories often through these mediums. But then in 2021, everything changed and the need for connection to nature became the gap that we aim to fill through our education pillar. This photo is just one of the interpretive signs that we've got out on the trails. So while our trails have been open since 2018, we decided to actually start advertising them in March of 2020. It was around the time that all the parks and natural areas closed down briefly due to the pandemic. And so we just wanted to throw it out there as an option in case people wanted to get out of the city. We had no idea that over the course of the next 2 years, we would welcome over 800 people to the Restoring 71 site. Over time, we started posting homemade interactive interpretive signage like you saw in the slide before. We created trail markers, trail signs, and inspirational quotes along the trails, trying to kind of target multiple age groups and interests. We offered what we call self-guided nature wanders, which were provided by appointments that people could book for social distancing considerations. And we offered guided tours when we could sneak them in between work and kid activities. We had no idea we'd be invited to write articles, be featured on websites and podcasts, or that we'd find ourselves in nature trail listings, and then even on Nature Canada's map of nature-based solutions. Most of all, I never expected to hear back from privately protected area lead of IUCN when we answered their call for case studies to use in future IUCN publications, especially considering that Canada does not recognize us as a privately protected area. So that was a nice win. So the element of education, though, at Restoring 71 that's most important to me is nurturing and celebrating the intersection of science, experience, and multiple ways of knowing to facilitate connection to nature. Entering conservation and restoration conversations as a landowner without a degree in agriculture, resource management, or biology is very intimidating. Applying for grants or even submitting abstracts to speak at events that use very academic language is also very intimidating. And so what we're trying to do is create a bridge between Western science and other ways of knowing and being, and celebrating those with equal love and attention. I'm not an avid reader, and so most of what I've learned about the land and how to care for it has not been from books. It's been from experiencing it and being open to learning from the land, and a lot of trial and error mixed in there too. We also apply elements of intuition to our management style, which I'm sure makes all of the Western scientists in the room feel a bit uncomfortable. It makes my engineering husband feel uncomfortable too. But it's little things like if I'm going to put down seed and something doesn't feel right about it, I just won't put seed there. There's a poplar stand on the site that we call Poplar Bluff. And one of the trails through the bluff makes me feel really uneasy. And so I just won't go through it and I won't do any restoration there. Alternatively, there's parts of the sites that we feel really drawn to, and we watch and we learn about those spots, and we figure out what the land's trying to get us to help it with. When I'm giving guided tours, I'm encouraging our participants too to experience the land with intuition. So it's things like, let's take that trail over there. It seems to be calling to us today. Let's choose a spot to sit that feels right while we do this activity. And by using this sort of language, it invites people to become more in tune and connected with their surroundings based on the way that those surroundings make them feel. So what comes next for Restoring 71? During this decade of ecosystem restoration, So this year we were very fortunate to have been awarded the grant from the Native Prairie Restoration Reclamation Planning Committee. And we'll use this grant to help us further develop the Pollinator corridor that I mentioned earlier. And this is going to be our primary focus for this growing season. And we look forward to sharing the results at the 2024 Native Prairie Restoration Reclamation Workshop. So that's exciting. In summary, we like to say that, this is a marathon. It's not a sprint. So we're going to keep protecting and restoring the land bit by bit. And we'll keep sharing this journey with anyone who will listen to us. And we're going to keep learning and listening and experiencing, and hopefully we'll inspire others to do the same. That is all I have for you today. I am very excited to hear any questions that you have.
All right, if people want to get into the chat or the Q&A with their questions, I can read them off and Katie can answer them. Fantastic presentation, by the way. Thank you for that.
Thank you.
I'll have to make it out this summer. And if anybody's in the area, they're open to visitors. Check them out, definitely. And follow their social media feeds. They've got really great stuff, particularly in the summer when they can post nice green photos. Yeah.
For now, we're just posting reminiscent photos of what summer was.
Right. The life of plant people, right? We have to just post about what has been or what will be during the winter. Yeah.
Exactly.
I've got a few comments. Donna says, fascinating. Look forward to visiting. Dorothy says, thank you so very much. Sarah says, great job, Katie and Aaron. Your efforts are commendable. I enjoy following you on social media. Derek says, very inspiring presentation. Good for you. Beckett says, very inspiring. Is disabling drainage tile part of your planned restoration activities?
We don't have any drainage tile. Our wetland, it's intermittent. And so it has actually been cultivated several times throughout the years. So we are just kind of following what Mother Nature wants to do with that wetland because it's come back. Probably every 10 years, it's back. And it's when we bought the land, it was a very nice looking wetland, lots of native vegetation around it. With climate, with the changing kind of wet cycles and dry cycles, it seems like we have years where it's very filled with invasive species and then it turns native again. And so we don't know what we're doing yet with it. We're watching and learning.
But you're ahead of the game that you don't have drainage tile that you have to deal with. Yeah,
exactly. One less thing to worry about.
That's right. Paula says, are you connected to the Treaty Land Sharing Network?
So we've reached out to the Treaty Land Sharing Network and we had a good conversation with the folks organizing it and decided that because we're such an active site, I mean, we get about 400 people through a year, that it doesn't quite, and we require appointments just so that we know who's back there for safety reasons. We don't quite fit the criteria for being part of the official network. So we like to think of ourselves as friends of the Treaty Land Sharing Network. And so we advocate for it and encourage other people to join who maybe don't have quite as busy properties, but yeah, we love it and join it or check it out if you haven't already.
Are there other questions either in the Q&A or the chat? Oh, yeah, lots. When they come in droves. Okay, wow, that was awesome. I was wondering how you stay motivated and focused on the big picture goals. Do you ever feel overwhelmed by how much there is to do? And if so, how do you get back on track? That was Joe that asked that.
Oh, that's a big question. Yes, we feel overwhelmed often, especially because we don't have the answers. And so we're learning it as we go. And so anytime we see a new challenge, we have to do a bunch of research to figure out a solution. To stay back on track, it's really the species at risk. Like right now, for example, we have a northern shrike that is visiting and he comes and he perches on the exact same branch every morning for 3 hours and scans the area, make sure it's good. And so seeing him every morning, it's like, oh, this is what we're doing this for. Same thing if my favorite spot on the whole site is the native patch. And so I'm out there every day in the summer checking to see what's blooming. And so that keeps us motivated. It's a little harder in the winter, but what we've been trying to do during the winter is really look for the opportunities to connect with nature in winter. And so we go looking for prints, or we post fun words about that are related to winter from other languages. And so we try and do things to inspire kind of love of restoration and conservation year round, but it's not always easy. But having presentations in February that you have to create where you need to go through all of your photos from the previous years of summer and wonderful, that was very therapeutic and helpful to get us inspired and ready for the upcoming growing season.
Okay, let's see. Yeah, Paula says, thank you. Laura says, thanks, Katie. Great presentation and great photos by Aaron. I agree. Stunning photos. Thanks for sharing. It is a great model for private landowners like many of us. You've keyed in on the challenges that private landowners are having while trying to restore and conserve smaller but important areas. Donna says, what is the IUCN? That's the International Union for the Conservation of Nature. And also the Habitats tool. It's Habisask, Habisask. And you can just Google that. Just type that whole thing, one word in, and it'll show up. And you can click on it. There's various degrees of detail, I guess, that you would have as the general public. You would see more or less, I think, what Katie saw with these large buffered polygons. If you were an environmental consultant, you would have much more fine scale data right down to like individual waypoints where those species were found. Sometimes they're buffered just so you know, people can't go pick an orchid that's shown on there, for example.
It also won't show you the names of the species unless you've got kind of the more advanced account level.
Okay.
See the species names, you'll see the blobs.
Okay, good to know. Good to know. Corin says, great presentation. Thanks so much. Very inspiring. Anna says, one of the beauties of being small is that you can mow areas of invasive grasses, which must be one of the most effective ways of knocking them back, but impractical on a large scale.
I would disagree. So the trouble with our landscape right now is that because it's an overgrown hay field, we could try mowing it and we will destroy our tractors. So we don't actually do a ton of mowing in the larger grass area. We need to come up with a different plan for that area, but we keep our trail done and any little spaces that we can walk and make sure that we're not going to kill the tractor when we do it. Yeah, I wish we could just mow it, but we have an itty bitty mower. It's only about 5 feet across. So we strategic mowing.
All right, what else do we have? Oh, Donna asked what, let's see. Okay, so Sarah, yeah, for those who don't know Sarah Vingy-Mazer, she's with the Saskatchewan Conservation Data Center. She has posted a link to Habisask there in the chat for people to click on. And then Dorothy asked again, what does the IUCN mean? It's International Union for the Conservation of Nature. So if you just Google International Union for Conservation of Nature, you should get that and more details about that. There is a web page for that. Any more questions? No? I'm gonna give it, oh, yep. Bev said, and she's another one who has a small prairie area that she has restored and is managing. She's actually east of Saskatoon, just down off Highway 5. She says, I utilize missionaries for manpower. I had to learn as I go by myself. Missionaries are motivated and sometimes they are even informed. Last summer, the son of a botanist from Alberta as my helper. Bev's had really great success in getting volunteers like missionary groups to come and help her do some of the hands-on work. Dorothy says sneaky, and Bev says 20 acres. So yeah, that's the scale of her area, and it borders another area that is owned by the province that is in quasi-natural habitat.
Nice. Cool.
Any more comments or questions? Oh, and Bev says in those 20 acres, 4 functional wetlands.
Nice. I'm still trying to decide if ours is functional. It's not right now. There's no water. Someday.
It's a cycle, right?
Yeah.
When it fills up, it'll be functional. Yeah. Laura says, are you able to bale the hayland, or is it too small for a renter to access?
So again, we tried last year when there was, so we were hearing from all of our neighbors that there's a horse hay shortage. And so we said, you know, we've got some hayland. It's old and overgrown. Come take a look at it. We had 3 people come take a look at it. The terrain is it was too risky to even get a tractor and a baler out back and a swather to be able to bale it at all. And so that was we didn't anticipate that was going to be an issue, but it's an issue. So we have to think of next steps, and it might just be we need a burn to start that, start the process of disturbance, to be determined. But yeah, haying is not an option. At least no one wants to take it on of our neighbors. So, which is fair, I guess, for tractor's sake. But.
Any other questions for Katie? I'm going to give it the old auctioneer. Going once, going twice. Oh, yeah. Oh, okay. So Bev in the chat has given her phone number. I can forward Bev's contact information on to you if you'd like to connect with her and have a discussion as to, you know, what you have in common, what you can maybe learn from each other. Bev's been super helpful to other people in the past, and she's been a long-time Native Plant Society member. Oh, and she's got the missionary phone numbers if you need helping hands. There you go. So I will connect the 2 of you after this event. If you don't get her number out of the chat right now.
Awesome. That sounds great.
Yeah. Anything else? Nope. Okay. We're right on time. I had this going for 45 minutes. We're 2 minutes over, but we had some great questions and comments. So I'm happy if everybody else is happy. So I'd like to thank you so very much for this. I think it's perfect. And when I was scheduling you, I thought, oh, wouldn't that be great if I had Heather talking about large scale public restoration, and then put Katie as the kind of opposite take on that, the small scale private, and let people compare and contrast, and both fabulous talks, both places I think everybody should try and visit. Yeah, just thank you again from all of us. Our next speaker, I'm so glad that we got her. I really wanted to get her to speak, and when I sent the original email, it came back saying, "Oh, sorry, I'm out of office." And then promptly after that, I got an email from her. So she's presenting to us from her mat leave. So even though she's on maternity leave, she's taking one for the team and pulling through for us. And I really appreciate that. So Lauren Bortolotti joined Ducks Unlimited Canada's Institute for Wetland and Waterfowl Research in 2016. She has a diverse scientific background with experience in avian ecology and wetland ecology and biogeochemistry. Her graduate research at the University of Alberta focused on wetland restoration, evaluating the recovery of biodiversity and function in Ducks Unlimited Canada projects. Lauren is involved in a variety of research projects ranging from evaluating waterfowl conservation efforts to quantifying wetland ecosystem services. She is broadly interested in research on wetlands and biodiversity and using science to advance conservation in Canada. And if you recognize the last name, you probably went to the U of S and had her dad as a prof. Gary Bortolotti was actually one of my wife's supervisors during her master's. So there's a bit of a connection there. So take it away, Lauren.
I'm speaking to you from Winnipeg, which is located on Treaty 1 territory, which is the traditional territory of the Anishinaabe, Cree, Oji-Cree, Dakota, and Dene peoples, and the homeland of the Métis Nation. I am very happy to join you today to talk about climate change mitigation and adaptation. The first part of my talk is really going to be about Ducks Unlimited Canada and how our work relates to climate change mitigation. So the what conservation offers for climate change mitigation in Canada part of the talk. And then the latter part of the talk, I'm going to talk about adaptation, specifically in the context of Ducks Unlimited Canada's operations. Now, I won't cover everything we do. It's an operation that goes from coast to coast, and there's a lot of facets of what we do. But in particular, I want to highlight the science that we're doing. So I work for the Institute for Wetland and Waterfowl Research, which is the science arm of Ducks Unlimited Canada. And I want to give you some insight into how we're thinking about adaptation. So for those of you who are not familiar with Ducks Unlimited Canada, we are an environmental nonprofit established in 1938, and we have partner organizations in Canada and in Mexico for a coordinated approach to continental scale waterfowl conservation. Our mission statement says that it's to conserve, restore, and manage wetlands and associated habitats for North America's waterfowl. These habitats benefit other wildlife, people, and the environment. And it's this latter part of the mission statement that really connects to this theme of mitigation. So the reason we can talk about how we benefit Canada with respect to mitigation really lies in how we practice conservation. And that's that we are essentially a habitat conservation organization. So Ducks Unlimited Canada employs me as a scientist, and that's an important role in that we're a science-driven organization. We practice adaptive management, but really my job is to help the organization deliver more habitat conservation, deliver better conservation, more efficient conservation. The goal is to get more acres restored and protected. And when we think about habitat conservation of grasslands and wetlands, yes, they're providing waterfowl benefits, they're habitat for ducks, but there are these other benefits, what we call ecosystem services, including carbon storage. And so really, by practicing habitat conservation, we are implementing natural climate solutions. So natural climate solutions are conservation, restoration, and sort of improved land management actions that either store carbon or avoid greenhouse gas emissions. And you may have also heard them referred to as nature-based climate solutions. That's a terminology that's being used by some federal programming right now. And my colleague, Dr. Pascal Badiou, worked with a team of scientists in Canada to quantify the scope of natural climate solutions in our country. And I won't go over all of the results, but I will just talk a little bit about the wetlands and the grasslands, as that's really what I'm most familiar with and hopefully of interest to this group as well. So to read this figure, you're looking at the magnitude of the climate mitigation potential in 2030 for a whole series of different climate solutions. The text is very small because it's from a PDF. So for wetlands, they looked at avoided peatland conversion. That's the largest, the action with the greatest potential mitigation in wetlands, although you can see from the error bars on there that there's a lot of uncertainty as to the magnitude of that effect. They also looked at avoided freshwater mineral wetland conversion, which I'll talk about a little bit more, salt marsh restoration, freshwater mineral wetland restoration, peatland restoration, seagrass restoration, avoided seagrass loss. And you can see that those first two, the avoided conversions, are really making up the bulk of the potential mitigation related to wetlands. For grasslands, they looked at avoided grassland conversion and riparian grassland restoration. But again, it's that avoided conversion that has the most potential, although we have, again, very large uncertainties that probably need to be refined still. I'll also draw your attention to the fact that they looked at the relative cost of these different actions, and unfortunately, we do see that very frequently these actions tend to be on the more expensive side. So the lighter gray is more expensive. Delving into the wetland results a little bit more, I think there's a really important take-home message from their research, and that's that avoided wetland conversion has a much greater potential for climate mitigation benefits than restoring wetlands. So the way to read these graphs, on the left, we have avoided wetland conversion. On the right is restored wetlands. The green dots are the wetland area, and the black dots are the cumulative net greenhouse gas reductions. And the framework the paper was using was looking at conservation delivery to 2030, and then the greenhouse gas benefits out to 2050. And what they saw is that there is both more opportunity for avoided wetland conversion than there is for wetland restoration. And there's also just a better reduction efficiency with avoided wetland conversion. And that's in part because when you restore wetlands, there's a release of methane, which is a very potent greenhouse gas that's going to offset a lot of the value you're getting from CO2 being taken out of the atmosphere as the wetland is restored. And so this, of course, has really important implications. It really suggests that we need to be keeping wetlands on the landscape and that it's not enough to destroy them and then mitigate with restoration. And of course, you know, for jurisdictions in Canada that do have wetland policies, there's supposed to be a hierarchy of, you know, avoid first and then restoration comes later. But it's unfortunately true that so often we do go to the restoration piece, but we need to know that we are not getting the same climate benefits out of restoring after we've, you know, drained or otherwise destroyed a wetland. There's been some work to assess the potential for natural climate solutions. This recent, or somewhat recent, I guess 2017 is now 5 years ago. So this study by Griscom et al. Looked at how much we need to reduce global carbon emissions to get to that under 2-degree warming pathway. And you can see from this figure that most of what needs to be done is reducing fossil fuel use. But there is a substantial portion of that emissions reductions that could be done using these natural climate solutions. And I think that it's really important to pursue this pathway because these natural climate solutions have co-benefits. So climate change isn't the only environmental crisis we're facing. I can assume that based on your participation in this organization, you absolutely know that we are facing unprecedented rates of biodiversity loss and that this too is a pressing crisis. And the nice thing about natural climate solutions is that if we're strategic, we have the potential to simultaneously tackle these two crises at once. Now, of course, if mitigation money was unlimited and we had all the resources at our disposal, this wouldn't be an issue, but that's of course not the case. And so I think there's a need to be very mindful of this and always be looking for ways to synergize and deliver solutions that will simultaneously tackle these two very pressing environmental crises. Now, before we move on to the adaptation section, I just want to touch a little bit on a sort of, I think, interesting and different topic. There is one other element of mitigation when we're talking about wetland conservation that is less talked about than carbon storage, and that's the ability of wetlands to cool the atmosphere. So if anybody's been to the coast or if you've spent time near like Winnipeg or in Toronto near a really large lake, you've felt how large bodies of water can affect weather and climate. And we've long known from studies using flux towers, which are basically micrometeorological equipment that you would set up beside a wetland, that there's a localized cooling effect around even small bodies of water. And what we wanted to know is, you know, in a landscape like the Prairie pothole region where you have a lot of small bodies of water, can that cooling effect add up to be something more significant at larger scales? And to do this, we worked with Dr. Yan-Ping Li at the University of Saskatchewan. Dr. Li is an atmospheric scientist. This was a very interesting collaboration. It's pretty different from what we normally work on. And I won't get into too many details now because I'm going to talk more about our collaboration with her later, but Dr. Lee uses a really sophisticated climate model and helped us look into this question of regional impacts of wetland cooling. And we were really interested to find out that indeed you can detect the cooling effects in the Prairie pothole region at much larger scales, sometimes in the order of 2 and 3 degrees Celsius. And that in areas with lots of wetlands, you can see, for example, a reduced number of hot days during heat waves, which has implications, of course, for human comfort, but also potentially for things like crop stress. So some potential benefits of having wetlands on farms. All right, adaptation. Also a really fascinating topic. I think to a certain degree, it's probably self-evident why we're interested in adaptation. Climate change is affecting absolutely everyone. There's no reason to think that our organization would be an exception. But this is a challenge we're taking seriously. And I want to walk you through sort of this multi-pronged approach we're taking to understanding how we may need to adapt in the face of climate change. So we want to know, how will climate change affect our mission? How do we need to change our operations to adapt to climate change? And with every expectation that climate change will affect the habitats that waterfowl depend on, are there going to be knock-on effects for the efficacy and efficiency of our conservation delivery that we will need to adjust for? Now, because you're located in Saskatchewan, you're going to be very familiar with the fact that this landscape has really strong natural climatic variations. This is probably a familiar sight to many of you. This is a lovely wetland dense landscape in a nice wet year. And, a short time later, the landscape can look very different. This is probably what it looked like last summer. And basically, these wetlands exist at a very fine balance between precipitation and evapotranspiration. And given that we know climate change will affect temperature and precipitation, we have every expectation that it'll affect wetlands. Now, why does this matter for emission? Well, we know from the waterfowl breeding population and habitat surveys that have been going on for years that waterfowl populations cycle with wetland abundance. So what you're seeing here in the solid line is duck populations, and in the dashed line, the blue line, are the number of wetlands or ponds on the landscape. And what's evident is that you get your highest duck populations when you have the most wetlands on the landscape. So the number of wetlands we might have in the future is going to be key to understanding if we can sustain waterfowl populations at a particular level. But we're also interested in where wetlands are located. We use a spatial targeting approach, so we don't deliver conservation equally across the prairies. We mainly deliver within these prairie habitat joint venture target areas, which are outlined on this map in black and labeled. And these target areas are largely defined by wetland density, which in turn correlates to waterfowl pair density, which is the actual colors you see on this map. So we want to know, when we invest in these landscapes now, are these still going to be good investments at the end of the century when the climate is looking different? Do we need to shift, or can we, are these going to remain good investments for waterfowl in perpetuity? So I told you we'd get back to our work with Dr. Lee. We worked with her and her PhD student, Zhejiang, to tackle these questions. And we were persuaded to work with Dr. Lee because of this really quite sophisticated modeling approach she uses. She used something called the Weather Research and Forecasting Model, or WRF. It's a numerical weather model that was developed at the National Center for Atmospheric Research, and has users all around the world. She uses one version in particular that's quite sophisticated. It has some of the finest scale climate predictions that you can get in North America. So climate modeling is typically done through general circulation models, which operate at very large scales that are not suitable for asking the kinds of questions that we're interested in. So what Yan Ping uses, the WRF model, is a regional climate model. So it's been downscaled from a general circulation model, And all this is done using supercomputers. So it's sort of mind-bogglingly computationally intensive. And it really gets you much better information. So the maps on the right-hand side of this slide really demonstrate that. So the column labeled CMIP5, that's a suite of GCMs. You can see how coarse those predictions are over part of Alberta and Saskatchewan, and compare that to the WRF model and the degree of detail that you get with that downscaled regional climate model. Now, what you get from WRF is pretty raw climate information. This is an example of sort of the output you get. This is just temperature. The top row is current, the middle row is future climate, and the bottom is the difference between the two. And then the columns read spring, summer, fall, winter. So this is great detailed information, but it's still pretty general. Same goes for precipitation. We know these are important variables, but they're not really going to help us exactly understand what's going to happen to wetlands. So to do that, we need to use yet another model. This one is a land surface model called NOAA-MP. And what's really fascinating and powerful about this approach is that you can use WRF and NOAA together and basically have the two interact in two ways. You can have the climate information drive the land surface model to understand what's happening to things like wetlands. But then the land surface model in turn influences the climate, which is how we can ask questions like, do wetlands have a cooling effect? So we now have this very powerful modeling framework, and we're ready to get to work. But there's always catches, and the first issue we had, and the first part to overcome in this project was that prairie wetlands were not adequately represented in this NOAA-MP land surface model. Prairie wetlands are quite unique. They're not like a lake. They don't hold water all the time. And we needed to essentially modify this land surface scheme so that we could appropriately simulate the effects of climate change on potholes. The ultimate wetland representation that we came up with was basically a combination of soil water content, which is a synthetic variable that includes the effects of precipitation, evapotranspiration, surface runoff, and groundwater recharge. So it's essentially including many of the hydrologic processes that we know influence prairie wetlands. And we combined it with a simplified version of sort of ecoregion effects, and that's just to account for the geographic differences in wetland densities that occur that aren't related to climate. And so collectively, these two variables allow us to reasonably simulate the distribution of wetlands across the prairies, so we can then use WRF to understand how these wetlands might change in the future. What did we find? Well, I think this is a little bit of good news, actually. I was pleasantly surprised that in the spring and summer months, so March to August, we see a general wetting trend across the prairies. Now, this is long-term average, so it doesn't suggest that we won't have dry years, just that the long-term average may be a little bit wetter than it has been. There are some exceptions to that. There is one area in Manitoba, just outside the prairie pothole region, that looks like we might have some consistent drying, but then there are seasonal effects too. So when we break it down by spring and summer, we expect to see wetter springs, and that's because of increased precipitation in the winter and in the spring. But in summer, we expect to see a drying trend, and that's because despite that, early precipitation in the year, temperatures are going to be sufficiently hotter that there's going to be higher evapotranspiration, and we'll see drier conditions, except perhaps in this area outlined in blue in that first panel in Saskatchewan. So we've got some spatial heterogeneity, we've got seasonal heterogeneity, and then of course there is still year-to-year variation. So a dynamic system as always. So now that we've completed that component of the study, the next step is to translate these future wetland distribution into the effects on waterfowl productivity. And this is what we're working on right now to do that, we're using what we call the waterfowl productivity model. It was developed by my colleague, Dr. Jim DeVries, who some of you might know. And the way the waterfowl productivity model works is it's spatially explicit. So for anywhere in the prairies, it can predict how many duck pairs of sort of the 5 most common species we're going to choose to settle there. And that's largely a function of how many wetlands are there. It can predict how many nests those ducks are going to initiate. And then based on the habitat preferences of those ducks and the availability of the habitat on the landscape, the model will distribute these initiated nests amongst the different habitat types. We then have a model that looks at habitat-specific nest survival rates that also takes into account factors like nest initiation date and latitude. And in the end, what it spits out is an estimated number of hatched nests. So there's a lot of science that went into developing this. This is a result of, you know, decades of research. It's all been summed up into this very powerful framework. So what we're going to be doing is using our future distributions from our work with Yan Ping to modify the number of duck pairs that settle. There's also a little bit of climate related information in the nest survival model, and we can tweak the waterfowl productivity model to see how that duck production is going to change under this future climate scenario. We're not done that yet. So what I've been talking about so far are largely these direct effects of climate change on wetlands and waterfowl. You know, basic questions of will wetlands still hold water? But there are these sneaky indirect effects of climate change. And the one that we're very concerned about is how climate change will influence agricultural economics and how that will in turn affect land use practices. So agriculture is currently, you know, one of the biggest forces shaping what our prairie landscapes look like. And we know that there's great potential for climate change to influence that through economics, through human behavior. And we want to take that into account as well, because ultimately, you know, these direct and indirect effects could be additive, but they could also be interactive. They could be synergistic. They could be antagonistic in their effects. And we really need to know the sum total to understand sort of the extent and nature of conservation delivery that's going to be needed in the future. So the final step is going to be to combine the work I've just described with these economically driven land use changes. And that's really just building off of work we've already done with Dr. Benjamin Rashford at the University of Wyoming. We worked with him and his master's student, Ben Beeman, using their econometric model. So they have a slightly different framework where they look at different climate change scenarios. So these RCP are representative concentration pathways, so different emission scenarios, and they looked at 3 time horizons, 2030, 2060, and 2090. And basically the further out in time you get and the more climate warming you get, the grimmer the picture looks. So basically, economic forces change such that there is incentive to convert grassland to cropland with greater climate warming and further out in time. And so we need to incorporate this information into the same frameworks. We have the waterfowl productivity model as a unifying framework to look at those direct effects and the indirect effects and sort of see how they sort out. And I think this is going to be really important because we have, you know, initial information that suggests maybe wetter conditions will be good for ducks, but then we've got the loss of grassland, and we need to know the relative importance of these different effects. So to wrap up here, you know, it is good news. We see evidence that perhaps conditions in the prairies might be wetter, but that's really not enough to say, oh, climate change is going to be no problem for ducks. That's not the case. We have strong evidence that those indirect effects may pose really strong conservation challenges. And we still have other questions. A big thing we haven't addressed yet is wetland drainage. We need to know how wetland drainage practices may be affected by these climate changes, by behavior, by policy. There's so many factors that influence this. And collectively, this information we can use to look at, you know, do we need to refine or change our spatial targeting? What are the greatest threats to our mission? How can we proactively address them? And we want to be able to do this so we can continue to deliver habitat conservation that sustains waterfowl populations, but also still continue to deliver those co-benefits related to climate mitigation and the protection of other biodiversity. So with that, I would like to thank the generous funders of the research that I've been talking about here, especially the climate change work with Dr. Lee. And with that, I hope we have time for some questions.
Yeah, we do have time for questions if anybody wants to. I'm looking in the chat and the Q&A. You've mesmerized them with your with your presentation. The chat.
Or I've spoken so
here we
quickly.
go. We've got some things come in. Bev says, "Bravo, bravo, bravo." I thought it was an excellent presentation. That modeling done by I can't remember his name, the professor down at the University of Wyoming. That is a pretty grim looking set of images for the future of Canadian grasslands.
It is very sobering. I'm not going to lie. But you know what? I think there is a piece of good news there, though. So the direct effects of climate change we can do nothing about, right? That's not under our control. But indirect effects are human mediated. And so we have a much better chance of intervening to change that. So very grim, but more tenable, I think.
Okay, that's good. That was going to be my question, is do you see a silver lining? So I guess that is the silver lining, and perhaps there could be, maybe the follow-up question is, what do you think could be done? Of the things that we can change, things like potentially incentives. I don't know if that was outlined in some of his work or not, but do you know of any kind of suggestions that he may have had at the end of any of his research papers that would serve as possible solutions to that?
Yeah, I think you point to a good avenue in incentives. That I should clarify that work sort of assumes that there aren't, major efforts to change that. So, for example, payments for ecosystem services of grasslands or whatever, which could very much change that outcome, because it's all about, profitability of farm operations. And so any financial instrument that changes that equation can absolutely shift those results. So yes, it's not something that is incorporated into those studies, but yes, your thinking is absolutely right on. That would be the first thing we would point to of how we might change the trajectory.
Okay. Are there questions? I'm looking in the chat. I'm looking in the Q&A window. Okay. Laura Poppy says, how does Saskatchewan not having a, in brackets, active wetland drainage policy complicate matters? For those of you with no kind of context to this, Saskatchewan does technically have a wetland drainage policy. They just don't enforce it ever. So I'll let you answer that, Lauren.
Yeah, that's a really good question, Laura. It definitely complicates things. I think it also points to the challenges here, because we have, different jurisdictions with different approaches to this. It adds a level of complexity to push conservation mandates and understand how you would need to adapt your programs. But I think the biggest problem that I see in the climate mitigation and adaptation context is that that work I talked about by Pascal really points to the fact that mitigation after drainage is not not a great thing from a climate mitigation perspective. So in Saskatchewan, we've got the double whammy of not even really, I'm trying to be careful how I say this, but you know, there's ongoing issues with wetland drainage, and you haven't even got to that mitigation stage. And so you're that much further away from the thinking of, oh, we really need to avoid these impacts in the first place, because, you know, it's really important to be paying attention to climate change mitigation. The other thing I will point out, I didn't talk about it in this talk, but in the work with Yan Ping and Zhe, we actually lined up the future effects of climate change on wetlands with historical patterns of drainage. And what you see is that there are areas of the prairies that stand out in that they have both high historical drainage rates and are expected to have outsized effects of climate change. And so what's going to happen in, you know, dry years, you're going to have a total lack of wetland ecosystem services because you've got drain basins instead of intact basins, which might hold water. And then in your equally hooped under wet conditions, because you're going to be losing, for example, flood mitigation potential, because you've got so much drainage and now you've got even more water than you used to in the past. So as always, it's the human dimension of all this really complicates things further, and Saskatchewan is definitely at the forefront of how complicated it is, because it's got these incredibly important landscapes that have so much potential to do good in terms of their ecosystem services, but that lack of enforcement around wetland drainage policy is really hurting those efforts.
I've got a comment from Laura. Excellent presentation. DU is doing some great research. Thanks. And if we have more in the chat or a Q&A window. Okay, Anna has a question. At one point, duck hunters, a potential source of money in the prairies, really cared about preserving wetlands. How do they stack up as a group that politicians listen to? Does anyone still hunt ducks?
That's an interesting question, Anna. Hunting is declining. There's an aging population, not as many young people are hunting. In the US, there are a lot of active programs to recruit and train and retain new hunters. In Canada, we don't have that same approach. I think that hunters, though, are still significant in conservation. It remains that hunters do donate more money to conservation than some other sort of outdoor enthusiast groups. And I think as far as their political influence, it probably depends a little bit on who's in power and their connection to those lobbies. But I think hunting still remains an important force in wildlife conservation. If you think about, you know, how provinces deal with wildlife, there a lot of resources are centered around harvested species. So although hunters are declining in numbers, I think they remain an important piece in conservation.
Are there any more questions? We still have a little bit of time. No? All right, looks like you're off the hook, Lauren.
Thanks so much.
That was a great presentation. I really appreciate it, and great insights into what could happen regionally here. So, you know, we're gonna try try to mitigate those impacts as much as we can, obviously, and see how it goes. And it's fortunate we've got folks like you and the other researchers that you were working with to give us those insights into what the future could hold for us, because we need to all collectively prepare for that. And you know, we can't prepare for that overnight, or we can't be reactionary. We have to be proactive about that. So this work is really integral to that preparation. Yeah. Anna says, excellent presentation, Lauren. Thank you. Dawn says, thank you for a great talk and great research. Yeah, I think that's it. So thank you very much. Appreciate your time, especially considering, you know, you have a little one somewhere that needs to be taken care of at the moment. So yeah, thank you very much for doing this. Appreciate your time, and have a great rest of your day.
Well, thanks very much. And I would actually love to stay and participate more, but I do have a baby who is going to need a nap shortly. So I'm gonna sign off, but thank you for having me, and thanks for listening. And it was great to participate in your AGM.
Great. Yeah, thanks very much. Yeah, enjoy the rest of your weekend.
Thanks so much.
All right, our next speaker is Dr. Stephanie Frischie. Stephanie serves as a plant ecologist role with the Xerxes pollinator habitat team. She has 21 years of professional experience in the field of ecological restoration as a practitioner and researcher. Her specific expertise is with native plant materials and all aspects of the native seed supply chain. Stephanie provides pollinator and beneficial insect habitat expertise in Canada, the US, and Latin America for a range of land use types: farms, energy infrastructure, natural areas, and urban green spaces. She also works with the native seed industry and researchers to plan and develop seed supply of important plant species for creating and restoring habitat. Stephanie volunteers as a rare plant monitor with Plants of Concern and serves on the board of the International Network for Seed-Based Restoration. Now, a little background between Stephanie and I met her one time, and it was right before the pandemic hit. I thought I'd have a lot more time to meet with you face to face at some point after that Prairie Conservation Action Plan Restoration Conference, but that didn't happen. COVID had other plans for us. So yeah, I haven't seen you since, but it's great to see you virtually, and we have connected up via email several times. So thank you for coming to speak today, and I'll let you take it away.
Thanks, Chet. I'm thrilled you invited me and that we've been able to stay connected somewhat these past 2 years, although, you know, remotely and in a limited way. And I'm glad to be participating in the Native Plant Society of Saskatchewan's annual general meeting. So my talk today is kind of split into two halves. The first, I'll talk about what I do in Saskatchewan, which is a pollinator habitat program between Xerxes and General Mills and their Cheerios brand. And then the second part of my talk will be on my work with the International Network for Seed-Based Restoration. And I don't know if we mentioned it or not, but I am based in Indiana. I'm about an hour south of the southern tip of Lake Michigan. So that's kind of where I'm joining you all from today. And that's why I haven't been back in Canada since February of 2020. But I'm hopeful for later this summer that it will be possible to travel again. I want to just provide a bit of background information to start about the Xerxes Society for Invertebrate Conservation. We're a science-based nonprofit. We are based in Portland, Oregon. And now we have over 60 staff spread out, many there in Portland, also in California and many other states across the US. But our work also takes place in Canada and Mexico, as well as in Latin America and occasionally in Europe. So our name Xerces comes from the butterfly pictured here, the Xerces blue. This was the first butterfly in the US to go extinct due to human activities. Its habitat was destroyed for development, and so roughly 50 years ago, Xerces was formed as a small but passionate group of butterfly conservationists with the goal to prevent future extinctions. And in that time, in those 50 years, we've grown. And essentially, we're organized among 4 project teams. One works to reduce the use and harmful impacts of pesticides. There's the pollinator team, of which I'm a part of, and we focus on pollinator habitat, agricultural biodiversity, and we do that work both through private sector channels and funding, as well as through government program funding here in the United States. And then we have an endangered species program. Several of our staff are a part of the IUCN committees for a particular taxon. And we are doing a lot of work in Western monarch populations and across the continent on bumblebees, as well as programs with fireflies and mussels. And then our communications and community program is where all of our publications, our outreach, our education, and some of our other urban and community-based programs are housed. I just also would like to mention that something I think Xerces is known for is all of our publications, and these are available online as free downloads. Some of these are just simple plant lists for various regions. Others are more in-depth guides or handbooks, as well as a few pamphlets and things. I pulled one out here, just best management practices for pollinators on Western rangelands, as another resource that may be of particular interest to everyone here today. And then we also have a social media presence, as well as a really, I think, well-stocked YouTube channel with lots of the videos that we've produced as we've gone to more remote training and technical support in the past 2 years. There's a lot of great resources there. And then we also have a few books that you can get wherever you buy books. We don't sell the books ourselves since we're a nonprofit, but these can be a good entry point for folks who want to learn more about pollinators, beneficial insects, and the plants that they depend on. 100 Plants to Feed the Monarch is here front and center. That's our most recent publication. It came out last year. And I'm just sharing a little bit more about monarchs. You know, the map here shows how, of course, the range of milkweeds in North America extends throughout southern Canada, and monarchs also make their way that far north and use those host plant species there. And then segueing into some of Xerces' work in Manitoba and Saskatchewan is our work with John Skinner of Skinner Native Seeds. He's there in Roblin, Manitoba. I'm not sure if he's joined in at this moment to the meeting or not, but this is Asclepias ovalifolia, or oval leaf milkweed, and the species of milkweed with the northernmost range in North America. And again, a few years ago when I was visiting John and some of his seed production plots, he was stewarding these plants here, and we got to see both larvae and adult monarchs on those. And here are a few photos from John and his seed shop with some of the follicles or pods of those Asclepias ovalifolia drying there on the lower left, and samples of all the, or I guess a hint from all those different bags that John is tending there of the many different native plant species that John has been able to supply to many users in the prairies, as well as to the pollinator habitat program that I'll be talking about. John's just been a real critical and good partner to work with. One more connection with native seed suppliers and native seed or native plant users is a new directory that we'll be launching in just a few weeks. This is a plant seed and services, a native plant seed and services directory. The website is up, but it's not populated yet. So there are many either regional or nationwide lists of suppliers, but often they just have a little bit of contact information and they're not updated very frequently. And I think that's really the angle or the niche that we're trying to fill here, is to offer much more detailed profiles of the suppliers. It's all based on information they provide, but it gives more information about whether they're selling local ecotypes, whether they have nativars or straight species, some of their pesticide practices that they use. So we want to know if they're kind of taking precautions to keep pollinators safe in the production side of these plant materials, as well as knowing if any of these plants may have been treated with systemic pesticides that then, when purchased, can make their way, into the intended habitat and cause detrimental effects to the very animals that they're meant to help there. So anyway, I just wanted to let you know this is happening. If you are a supplier and haven't gotten an email from us yet about how to include your listing here, please reach out to me. And if you're looking for this, then we'll be launching and announcing this in a few weeks. So I mentioned that one of the ways our pollinator habitat teams work is through the private sector. And another offshoot of that is Be Better Certified, which is a third-party certification that farms can go through. There are 4 main areas where they have to enact and demonstrate practices that are pollinator friendly. And those include permanent habitat, which has a requirement of a certain percent has to be a native plant species. And then there's also a temporary flowering habitat requirement, as well as practices related to insecticides and other pesticides, practices related to managed pollinators like honeybees and like some of the bumblebee or bombus species that are managed. And then that there's adequate record keeping and transparency in these. So so far we've worked with several growers of blueberries as well as almonds. And in certain markets in the US, these products are now hitting the shelves and consumers are able to see this other option or choice or have more information about how the food they're choosing to purchase has been grown. With General Mills, we work in California a lot with various different brands. Some of those are looking at Be Better certified. Others are voluntarily also putting in pollinator and beneficial habitat. And the Cheerios brand wanted to support pollinators as well. Even though oats, the main ingredient in Cheerios, are a grass that's wind pollinated, they're often grown in rotation with canola and flax, or even soybeans can benefit from insect pollination. So adding permanent pollinator habitat into those farm landscapes where Cheerios are sourcing oats from is the main goal of this program. So it's a 5-year program. Now it's in year 6. We just kind of needed to extend it because of the pandemic sort of upending our plans here. But in 2022, we're still offering seed mixes and technical support to farmers or landowners and other land managers who feel this is a good fit for them. They may be growing oats, or they may just be in kind of the sourcing regions for General Mills that qualifies you. And essentially know that you're committed to maintaining the planting for at least 5 years and offering some pesticide protection and looking at increasing the biodiversity on your land. So those are the general guidelines of who would be a good fit for this program. And these are some of those other ancillary or stacked benefits that come along with pollinator habitat. So this program has mainly focused on Saskatchewan and Manitoba in Canada, and then the Dakotas and Minnesota in the US. And for the Canadian side, we've just had so many partners that have made this work possible. All the farmers who participated to date, I've now tallied that up to 77. Patterson Grain, the different seed producers, again, I mentioned Skinner Native Seeds, Prairie Originals, and North Star Seeds have been the main suppliers that we've worked with. The Native Plant Society of Saskatchewan, I've appreciated having Chet to go to as a resource on recommended species to include, as well as Sask Organics, Nature Saskatchewan, NRCS, the US Agency on Natural Resource Conservation Service, the other watershed offices, and then several other pasture, forage, and government and university groups. And that was my list version of all the partners that we've worked with, and then this is my photographic version of that same list, showing all the partners and researchers and conservation employees that make this possible. And but then we get, bee friendly Cheerios on the shelf in the store. I want to just share a few of the farms who participated in some of the seed mixes that they planted. So this is Heritage Ridge Farm. Patty and Andrew, they're part of General Mills' larger regenerative ag program, and this pollinator program kind of nests really well within their existing and larger farming philosophy. And they planted 10 acres in 2020 between a field and then a tree line. You can see here from the species that were in their seed mix, this is a mixture of tame species and native species. And we kind of offer that flexibility to participants in the program. Some of them are grazing or haying the habitat while still letting it go to bloom and provide benefits to pollinators. For others, it just may be a saline area or an area that's often pretty wet and hard to get equipment in, and they more permanently want to just leave it in different vegetation rather than farm it. So this is an example of one of those seed mixes that has native and tame species in it. I think at both of these farms and locations, we did native seed mixes that fit better into their goals and plans. And this, I think, again, thanks to our seed suppliers and Skinner Native Seeds, we had just this wonderful, pretty rich list of species to work with here, of 34 non-legume forbs, 8 legume forbs, 10 grasses, and 1 shrub species there. So the overall acreage target that General Mills wanted to aim for was 3,300 acres. These numbers aren't quite accurate, but it's kind of roughly where we were. We didn't get quite as much progress done in 2020 and 2021 because of the pandemic, but with another 800 acres as our goal for this year, we'll reach our 3,300 acres. And this map just shows each dot is one of the participating farms, and the colors are the different years that the planting happened, and then the red shaded areas are the areas where General Mills is sourcing their oats from. So those are kind of the higher priority areas, but we're not limited to only working in those regions. Again, we've been able to partner with different groups like Manitoba Beef and Forage Initiative. And this is at one of their paddocks outside of Brandon, where this pasture had pretty much just become grasses, and they wanted to do a couple different seeding experiments to try to enrich that with more legumes and other species. So again, we did a mixture of tame species and native species in the seed mix. That's what's listed here. And then they also did 2 different types of like suppression treatments. So one was where they did mob grazing and brought cattle in for an intense period of a few hours with a lot of cattle per area to try to break up a lot of the rhizomes of the grasses. And the other treatment was an herbicide treatment. And then there were 2 seeding treatments that were also done in a factorial design, seeding with a drill on both of those site treatment practices, and then doing mob grazing where the cattle also, the seed was broadcast by people, and then the cattle were put in again to work the seeds in to the soil with their hooves. So we had some initial results the first year, but then also another drought year. And then they replanted some of these. And I'm hoping again to get back up there this summer and just, take another look, another snapshot of this, and see in what kind of the final answers or recommendations are able to come and what we've learned from this experiment. And yeah, there is a little bumblebee here hiding in that receptacle of the sunflower here. Another good collaboration that has come of this is with researchers at the University of Manitoba and several growers, where they put in the seed mixes, and then the research team has come in and set up various types of traps for insects. And so some are here along the edge, and then they've also been collecting samples on perpendicular transects into the crop fields to measure kind of how far pollinators or beneficial insects are moving. Here, Scott wanted to do an eco buffer, and then there's also another pollinator strip that's perpendicular to what you see in the picture. And so, even though he was, this picture's from the first year after seeding, so he was doing a good job mowing to keep down annual weeds while these perennials were establishing. So the photo on the left doesn't look like there's a lot of floral resources there, but once you kind of got down and looked, there were. And then we even had, it's maybe hard to see here, but there's an ambush bug in that top center photo that has captured a drone fly. So there's ecology and food webs happening right there. So just kind of summarizing the program, our goal again for 2022 is 800 acres, and I'm currently recruiting new farmers or land managers. So please, I'll share my contact information at the end here, reach out to me. And I am glad to be continuing and expanding our partnerships in the Great Plains and in the Prairies. And we'll be making site visits, fingers crossed, this coming summer, and also following up just through online surveys with farmers who have participated. And then we'll be looking and talking with General Mills about any new directions for 2023 and beyond into the future. There's just been a great response to this program, both from General Mills and from the farmers. So we're not sure what shape it will take, but we hope to continue working in on-farm pollinator habitat. All right, now we're gonna switch to a different slide format, and the second topic here, the International Network for Seed-Based Restoration, or INSR, which is a thematic section of the Society for Ecological Restoration, SER. So our website there is ser/INSR.org. And Again, we're a network nested into this larger professional organization. Because we're international, we've largely been virtual even prior to the pandemic, but we bring together professionals, scientists, practitioners, students, industry, government, and other organizations like Botanic Gardens who work in some aspect of native seeds and ecological restoration. We currently have 854 active members from 64 countries, and kind of some of the work we've been doing during the pandemic. Big products are training modules. These are recorded videos. They were funded through the U.S. Bureau of Land Management. A lot of staff of that agency have more been trained in what's good for cattle, and they're missing sort of part of the larger ecological background and perspective. So we hope that these training modules will help in their professional development. And then we also produced a special issue of the journal Ecological Restoration, and all that's focused on kind of different aspects of the native seed supply chain. And I'll talk a little bit more about that too. So again, prior to the pandemic, we also organized and hosted either sessions or symposia at conferences. This is one of the Society for Ecological Restoration's global conference in 2019. It was in Cape Town, South Africa. So we had several workshops and sessions at that conference. In 2021, I've got Quebec here in quotation marks because that was intended to be the host city for actually 2020, and then it got postponed to 2021, but was still decided to not hold an in-person conference, but rather it was all virtual. But a lot of the people who organized it were based in Quebec, so it still certainly had that flavor. And one of the workshops that INSR organized at that meeting was titled Networks and Other Strategies for Developing Regional Native Seed Supply to Meet Restoration Needs. We had, it was a 2-hour workshop, and there were just really a lot of lightning rounds by the 7 different regional seed networks that are listed here. So from Canada, we had the Southern Alberta Native Seed Collaborative, and also the Ontario Plant Restoration Alliance. So again, I'm assuming many of you are familiar that it's kind of this cart and the horse or chicken and egg scenario. Users want native seeds, but it's a lot of risk or capital and time that someone who's going to produce or provide them needs to commit to upfront. And so there's this disjunct between the supply and the demand that just the private sector has not always been able to meet. So these different networks and kind of regional collaboratives are one of the solutions that work to address seed need for their region. So I don't know if that's something, that Saskatchewan has talked about or might be helpful, but maybe that's something we can save for the Q&A portion. Then we also have, INSR also has a YouTube channel, and the recording of that workshop is here. It's the first one here, Networks and Other Strategies for Developing Native Seed Supply. So if any of those that I listed in the previous slide piqued your interest, you can just visit the INSR YouTube channel and watch that recording. And then we also have a few other webinars and trainings that were recorded on here, as well as some other kind of technical tutorials. Again, we're mostly based online. So there's our website, but we offer webinars. We post opportunities like jobs and other events related to native seeds and restoration, and also have Facebook, Twitter, and Instagram accounts. I wanted to go back and spend a little more time talking about this special issue of Restoration Ecology. This was published in August of 2020, and it is loosely titled the International Standards for Native Seeds in Ecological Restoration. It was published open access, so anyone can go to the journal page and download the articles. There are 9 articles in this special issue. They essentially, are organized in the same progression as the native seed supply chain here. So number 2, starting with how you need to think about planning and sourcing strategies and different procurement options for a given project. What is entailed in either collecting or the cultivated production of seeds. Ways to ensure seed quality, really looking at the cleaning and testing aspects of seed production and seed use, then seed storage and how that's really critical for maintaining seed quality. And something then a bit more basic science, just an article about dormancy and germination, understanding those aspects of seed biology and what to know about them when working with native seeds and restoration. Also seed enhancement. These might be things like priming or seed encrustment, which are especially important for seeds that have maybe really strong types of dormancy or are going into arid areas where that can be a bottleneck or a big source of mortality is germination, but then no moisture. So there's different seed crusting technology that's being developed to kind of keep more moisture around the young seedling until its roots are able to grow enough and withstand drought. Seed use in the field, actually doing the planting and then the post-planting management and monitoring, and then a final article that is more about offering templates for seed tracking or seed testing, record keeping. This is a slide that just has a few of the images or the figures that were used in some of those articles here to give you a taste of what's all included in there. And then other work that INSR is active in are what we call news items. So anyone working in native seeds is welcome to contribute a news item, and this is posted in that section of our website. And so back in December, we have genetic differentiation of populations restored using regional seeds. So that's looking a little bit more at like, is local better or does it matter? And then just earlier in February, Royal Botanic Gardens Kew in the UK, they host this great resource, the Seed Information Database. And it's free and really easy to use and accessible, and it contains information like average seed weight and storage behavior and some kind of what to expect in terms of germination percent for different treatments. And Q was going to be taking that down. Kind of there were some other web-based problems why they weren't able to continue hosting it, but INSR has reached out to Q and is now negotiating ways that we can help them continue to host this database in the next few years. They're transitioning to a different kind of global seed forum, but we didn't want to see the seed information database go away in the meantime. So that's something we've been active about recently. And also in advocacy, this is an issue that European native seed producers are facing. A lot of the producers of forage seed species are trying to kind of lump native seeds under that same umbrella in legislation, and it doesn't really suit the biology of native seeds. So the European Native Seed Producers Association and INSR have been providing comments and weighing in to kind of defend against this kind of legislation that could set native seed production back. if all this has you really excited or interested in INSR, and you'd like to know more about becoming a member, first you become a member of SER, and then in joining, you just add INSR to your SER membership. And again, we want to make this accessible to as many people as possible. So just depending on your situation as either an individual member or an organization or a business, there are different membership rates and categories here. Then we also have what we call the ambassador program. These are any SER or INSR member who wants to be more involved, but not to the degree of serving on the board. And these are just, some ideas. It may be things that you're already doing locally, but you can kind of help provide news articles about your local work to the network, provide some local technical information. When we have local events again, share INSR materials. These last 2 points are like a bit more concrete. We're working now to translate those international standards articles into Spanish and Portuguese so that they're more accessible to practitioners around the world. And we may do that in other languages as time goes on. So if you'd be suitable and willing to help with that, that's something else we could use assistance with. And then we have another systematic review of the literature kind of on native seed markets globally. And we could use some volunteers who would be interested in helping to work on that project. And you would potentially become co-authors in that final publication as well. So that kind of wraps up my two-part presentation here. If you want to get in touch with me about the Cheerios Xerces Pollinator Habitat Program, there's my email at Xerces for that. And then to learn more about the International Network for Seed-Based Restoration, there's an additional email contact for that group.
Thanks very much. That was a great presentation full of so much information. Before we take questions, because I know somebody's going to ask, no, the Native Plant Society does not have the budget to have their AGM in Cape Town like the SER did. So that's not going to happen unless we get bigger and better funders. I'm not saying, never, but we're really, really going to have to increase our budget before we can do that. I know we all want to get out of Saskatchewan when it's winter and it's -40, but that's going to be on the back burner, I'm going to have to say. Are there any other questions other than that one? Again, in the chat or the Q&A box, it doesn't matter. I'll monitor both of those. And yeah, Stephanie in her talk had mentioned John Skinner several times, as did I, if you remember. John Skinner had provided the seed for the wildflower corridor along the Highway 5 going east of Saskatoon. And that those bags of seed, I don't know if you can remember back to that slide where John was in this kind of seed cleaning facility. It was a Quonset looking building, and there were all of those white poly bags stacked up on a pallet behind him. Each of those, depending on the species in there, several $1,000s a bag, just because it's so labor intensive to grow and harvest and clean all of those. So yeah, it's a really labor intensive and often expensive endeavor to do this on a large scale. So those are, just some of the challenges there. But yeah,
I would just
fantastic.
Add, he's fantastic. And I would add, that's really what makes projects like this pollinator habitat one possible, is having a source. I want to use local native plants as much as possible in these. And, John had the right background and skill set and motivation and spirit of, let's try it, to work with that. And this program kind of had a long enough time frame that we could plan ahead and give him a longer runway to either wild collect the seeds or put some of them into his production beds. So that's, you know, kind of a good example of how some of these partnerships can work.
Yeah, yeah, absolutely. I believe John Skinner has also done some contract growing for Grasslands National Park, tying into, you know, what Heather Facette was talking about there. So there's been a lot done there, and yeah, the lead time you mentioned, we did a survey of the needs of the producer end and the user end of the native seed industry in the Canadian prairies, and that was one of the big ones for the producers. They can produce what you want, but you have to give them sufficient lead time. So that, you know, that you have recognized that is going a long way to project success there. Yeah, yeah.
Yep. And also from the consumer, the user side, I would always recommend or encourage you to ask, right? I mean, you may assume that a certain species or ecotype is not available, and maybe it's not in that moment, but keep the channels of communication open, whether it's, you know, through the nexus of the Native Plant Society or directly with seed producers or other folks working in that space, but just let them know what you ideally would like to have. Just because it's not available off the shelf that year, it doesn't mean it can't start to get in the pipeline.
Yeah, absolutely right. Heather Facette with Grasslands just said, since the early 2000s, John has been growing blue grama for the park. So there you go. Yeah, over 20 years of involvement. And Anna says, regarding oval leaf milkweed, monarchs find these plants as far north as the Nisbet forest, lay eggs there and produce a population that hatches and flies south in the fall. So the Nisbet forest, for people who aren't familiar, is about 100 kilometers north of Saskatoon. So yeah, and I think you, Stephanie, had mentioned that it's the milkweed with the furthest north distribution.
Yep.
Yeah. So Heather Pete Ham says, would the program work on the west side of Saskatchewan, even if somewhat distant from the red areas? She meant the farmer seeding program.
Yeah, that's certainly possible. Like I said, those kind of red shaded areas were the priority areas, but any other appropriate farm or situation elsewhere in Saskatchewan or Manitoba, we'd like to talk. Yeah, these are eligible.
All right. And Beckett says, does Xerxes support using seeds of species from other regions of North America in restoration?
Yeah, so thanks for that question. We're a conservation organization, and so in general, we support using species that are native to a specific region. I think we're also working in more agricultural spaces than purely natural area spaces. So certainly in natural areas, we would follow the recommendations of reference ecosystem and using the species that are native to that area. Some of our work though in agricultural systems, we're using kind of these hybrid mixes like I showed you with some tame species, or we're working with cover crop species that, you know, are also tame or may have their native origins in Europe or elsewhere. But we do try to avoid ones that are known to escape cultivation and become invasive, or, you know, seem to have the potential for that. You know, Melalotus, I think, is one of those examples. Of course, it's a good forage plant for livestock and for honeybees. But depending on where you are, it's like escaped all over the landscape and displacing a lot of native vegetation, or it has the potential to use that. So we definitely avoid and do not support the use of those invasive species, but for some of the well-behaved tame species, we do include those when the situation is appropriate.
Are there any other questions coming in? While we wait for some, I'll just, you know, related to Stephanie's talk and all the other ones about restoration, I always tell people who want to know more about it, and this is dating myself, if you remember the movie Field of Dreams, if you build it, they will come. That's what I always tell them. You know, if you build it, they'll come. If you put the native plants in, the wildlife will show up. You don't have to have a big billboard. The flowers and the native plants are, the calling card, and then they're, it's like they're drawing in that wildlife. And it doesn't matter if it's an agricultural landscape, if it's surrounded by agriculture, there's still benefit to these pollinator corridors or pollinator patches, even if they're completely disconnected. Even my small yard in Saskatoon is surrounded by other yards that have nothing but lawn. And we've had all sorts of stuff. Last year I had monarchs. Some years I don't have monarchs, but some I do. And the monarch migration and numbers are through the Saskatoon area is kind of cyclical. But last year I had one, and I do have milkweed. I'm not sure that's what drew them in so much as all of the other native species that were blooming. And this one monarch could consistently be found sleeping on meadow blazing star, Liatris ligula stylus, would just suck nectar till it fell asleep on the flower, and it was so adorable. And I got some really great pictures, because it was sleeping. And yeah, you'd go in the morning, and there it was again, still sleeping, was there all night, and just hung out in my yard for probably a week before it moved on. And we've had as I've said, insect identification knowledge is pretty rudimentary, but my wife's is getting pretty good, especially with some of the bumblebee species. And we've even had some bumblebee species at risk in my yard in Saskatoon. They don't care it's a yard in Saskatoon. They just see the Gaillardia and they see all of these other great nectar sources. So yeah.
Yeah, and I guess, also to mention learning ID, iNaturalist, of course, is just this ever expanding great app that so many naturalists and scientists are members of or have accounts with also. So you take the photo of whatever organism and you may kind of give it your best guess of what it is, and that can be based on the location as well. And then other experts will look at your photo and offer their suggestions of what they think the identification is or verify yours. And that's kind of like a really nice student-teacher relationship that can kind of help individuals learn identification of plants or of bees.
Yeah, that's a good point. I do that all the time with things I don't know. One of the greatest parts about that is you just upload a photo and go, I have no idea what that is, but I'm asking the larger community to put their heads together and try and figure out what it is. You have to have good pictures. You can't give them this blurry thing from 3 meters away. But if you give them what they need, they'll come back with a positive identification almost every time. The other good resource for that is bugguide.net. But it doesn't map it. I don't think so. It's less useful for conservation practitioners, I think, than iNaturalist. But yeah, it's great that you can just pose this question and just say, I have no idea what this is, but that's for all of you to figure out, and I appreciate whatever you come up with. Yeah, it's great.
Yeah.
And I try and pay it back by IDing some of the wildflower species that people post that they don't know what it is. So I'm not just parasitizing iNaturalists. I actually try and contribute back with what I know. Are there any other questions? Let's see. Yeah, there is. Andrew says, I've looked into previously securing seeds from the US for restoration projects and ran into issues with the quality of seed due to differences in regulated species from the US to Canada. Have you ever encountered this from the reverse side going to Canada from the US, or do you source your seed from the country where the project is occurring?
Yes, so there's like the different legal frameworks, the different customs and border crossing requirements. And while we looked into sourcing across the international border, we just decided, both because we wanted to work with local companies and producers. In either case, we're sourcing for the Canadian projects from Canada, and we're sourcing for the US side from US producers. certainly there are companies, not to speak for North Star, but they're set up to import. I'm sure some of their production is happening in the U.S., but they're set up to follow the right procedures to import seeds. And hopefully the testing. I guess if you're always concerned that there's going to be a regulated species in your seed mix, you can request a test based on your jurisdiction for that lot before, or as a condition of purchasing it. You're concerned that there's certain noxious species in there.
Yeah, and I guess I'd add to that I think some of the bigger seed testing labs in the United States do know how to follow the Canadian seed testing procedures. There's differences, but I think the major seed testing labs know what to do for either. Yeah. Yeah. I think we're right at time right now. So if there are any other questions, maybe put it in the chat and maybe we can answer them through the chat. I'd really like to thank you. Hopefully you can make it up to Canada. If you're in Saskatchewan, let me know. We'll have to have our second ever face-to-face meeting. And yeah, I just want to thank you for all of that great information. Just to tack on one little plug for the Native Plant Society, we have spent this winter updating our native seed producer provider list. It also lists those who provide seedlings as well, if you want to start with that. We're getting that list just updated. The old list is still on our website. It's more or less still valid, but we want to refresh that. We try and do that every year. We've got a little online listing. It's like a Kijiji style kind of online classified on our website. Right now, it's only for native seed and plant producers who are Native Plant Society members. It's kind of one of the perks. So there's that. We certainly will link to your initiative once that's populated. We'll put a link in our newsletter. And then the same thing for that PDF. I noticed it didn't have the most easy to remember web address. So what we'll do is we'll give that a shout out somehow, either in our newsletter or through social media or something like that. So that and this will also be on YouTube, so people can pause this on YouTube and then write that address down for that journal. So yeah, thank you again. It's been wonderful, and hopefully we can see each other face to face one of these days.
Yeah, agreed. Thank you. And I always enjoy kind of seeing all the conservation work and perspectives that are happening in Canada too. It's inspiring.
Yeah, it's great to learn from each other, no matter where we are, Yeah, it's perfect. Thank you again. All right, our next set of presenters. It was a great surprise when I was putting this together because I had reached out to Beckett. He's on our board. He's our VP and also a master's student at the U of A. And I said, "Oh, Beckett, I'd really like to grab somebody from the U of A to get a different perspective, different set of expertise involved." And I thought maybe he would just do one, but I got 4 for the price of 1, and the price was 0. They're not getting anything except for our utter appreciation. So I was really pleasantly surprised and quite lucky that I was expecting 1 and got 4 presenters. So I'll just give their brief bios here, and then I'll let them take it away in whatever order and fashion that they want to. So we'll start off with Dr. Valerie Miller. She's the coordinator of the Land Reclamation International Graduate School and will be presenting on the program, its outreach initiatives, and hosting Become an Earth Doctor. She completed her PhD in land reclamation at the U of A in 2019, focusing on building soils using waste materials at a northern diamond mine. Beckett Stark was born in Saskatoon and will tell anyone who will listen that Saskatchewan is more than just flat canola fields. Hear, hear. During the summer, you will find him botanizing and collecting native seeds that he grows during the winter to be planted at a prairie restoration on his family's homestead. Next up is Chen, obtained her BSc in Environmental and Conservation Sciences at the University of Alberta in June 2019, and started her master's in land reclamation under supervision of Professor William Shoddick the following September. And finally, we have Kiah Leight, is from Edmonton, Alberta, and is currently pursuing a Master of Science in Land Reclamation and Remediation at the University of Alberta, supervised by Dr. Robert Grant. Kiah completed her undergraduate degree in Environmental and Conservation Sciences at the U of A in 2020. In the future, Kiah would like to apply her knowledge of environmental science and ecosystem modeling to help provide innovative solutions to environmental problems. So take it away.
Thank you so much, and thank you for having us. Can you hear me okay?
Yes.
Okay. I'm just going to make sure I can share my screen. We can see the screen okay? Awesome.
Perfectly.
So today we're kind of going to be all over the place. I'm going to introduce you to our land reclamation program, and then each of our three presenters is going to spend 5 minutes sharing their work, followed by a Q&A period. So ask as many questions as you want. And then at the end, we're going to go a little bit different, and we are going to play our land reclamation game. So we hope that you will join in at the end. But first, a little bit of background about me and our program. So as was said, I have a Bachelor of Science in Biology and Environmental Science, where I studied birds in the Arctic. So I spent summers in Nunavut in the Yukon studying birds, and I really fell in love with the Canadian North. So I went back for my PhD in land reclamation, focused on building soils at a northern diamond mine. And now I'm the coordinator of the Land Reclamation International Graduate School, the program I'm going to share with you today, as well as the Outreach and Engagement Coordinator for Future Energy Systems. So land reclamation, as many of you know, is the process of converting disturbed or damaged land to its former or other productive uses. Restoration in particular is a specific kind of reclamation focused on returning the land to what was there before. And our program, the Land Reclamation International Graduate School, is all about helping train students in land reclamation. So it was established in 2011 with an NSERC Create grant to provide collaborative and interdisciplinary training and professional development opportunities for students, grad students, and the goal is to foster highly qualified land reclamation practitioners. I like to say that our program is all about learning beyond the classroom, and it is the first program of its kind in the world. So the vision of LRIGS, the Land Reclamation International Graduate School, is to establish a world-class program that provides value-added training and professional development for individuals at the U of A, but also in universities and colleges outside of the U of A who are planning careers in land reclamation, whether that be from a science side, a social side, or anywhere in between. The program will meet the needs of scholars, practitioners, industry consultants, regulators, reflecting that diversity that I mentioned of different kinds of programs related to land reclamation, and for each individual helping to expand the understanding and the depth and breadth of land reclamation. So why do our members join the Land Reclamation International Graduate School? A few of these reasons include to broaden your perspectives on land reclamation. As someone studying soil science in land reclamation, LRIGS gave me the chance to learn from students more on an engineering side or a social side. So it really broadens your perspective. You also gain knowledge and hands-on experience through various training programs. It increases the awareness of legacy and current and future reclamation needs, as we're constantly talking to practitioners and learning about what has worked in the past and what is going forward. It is largely about networking, so giving students, researchers, working professionals the opportunity to meet and engage with each other, as well as the opportunity to learn about diverse career paths and improve employability. And as I mentioned, LRIGS is open to any undergrad and graduate student, postdoctoral fellows at post-secondary institutions anywhere in the world, essentially. Right now, we are all members from the University of Alberta, but we do the majority of our programming online, so it is open to anyone. As well, it is open to any faculty, whether that's science, engineering, arts, environmental science, business. It's for people with a passion for land reclamation, 3 of whom you're going to meet today. And the activities that we do include various lecture series. So our next month, we have someone talking to us about seismic line restoration. We do professional development programs. So in a week, we're doing a session on how to improve your technical writing skills. So they range in scientific content to those soft skills that we are really developing. There are opportunities for networking as well as a mentorship program to help you advance your career forward, as well as short courses and field trip and our outreach program. So outreach I'll touch on later because it is going to be a main area of focus. So now we are going to jump into our research presentations. As I mentioned, each student is going to have 5 minutes to present, and then we'll pause for a question or two, and then we'll go to the next presenter, question or two, next presenter, and then a big Q&A at the end. So if you have questions, pop them in the chat, and I will keep an eye on that and make sure that I can ask them for you. So I'm going to stop sharing so that Beckett can share. Beckett is going to be our first speaker. I can see your screen.
Perfect. And the right screen's up?
Yes.
Perfect. Okie dokes. Hi, everyone. My name is Beckett Stark. I'm an MA student, which I guess is master's in agrology, land science. And I'm also the vice president of the NPSS. But I must say, Chen and Andrew make my role very easy. They run a tight ship. The biggest benefit that I've gotten from being a part of LRIGS has been the mentorship program. I've gotten really good opportunity to speak with established environmental professionals, restoration professionals as well, and that's been really beneficial for helping me prepare to get jobs and such. Okay, so I'm going to start off with a bit of a rhetorical question that I'd like everybody to think about. So the question is, how do we know what impacts industrial development will have on the landscape? Okay, so while you're thinking about this, in this talk, I will present some examples from the literature that highlight the strengths and weaknesses of rare plant mitigation during pipeline construction on the Northern Great Plains. So first off, what is rare plant mitigation? Rare plant mitigation is an attempt to balance conservation of rare plant populations from industrial development. And I really want to highlight that the emphasis is on preserving the genetic diversity and the persistence of a population of rare plants rather than protecting individual plants. On your screen here, we have northern white violet, one of my favorite rare plants. Okay, so the first example I'm going to talk about is the Trans Mountain expansion, the Anchor Loop section, which I guess is in Jasper National Park. And so this project really effectively utilized locally collected plant material for rare plant mitigation. So the rare plants in question were Hooker's cinquefoil, Sitka columbine, and poverty oak grass. And yeah, these were all locally collected genotypes that were in the park, and they were stated to the company that they were very important to the conservation vision of Parks Canada. So seedlings were produced in a commercial nursery and then transported to a purpose-built greenhouse that was on site for storage and acclimation. And that's the photo on the left there. So then the transplants were outplanted into what were referred to as forb islands on the pipeline right-of-way once construction had been completed. And so that's the picture on the right. And these 4 myelins, I guess, were mass plantings of the flowering plants, several shrub species as well. And they were actually intensely irrigated for the first growing season to help facilitate establishment. And they were actually very effective. I was really surprised to learn that some of the plants even produced seed in the first growing season, which is pretty atypical for some of these projects, especially given how dry it's been recently. So the second example I'm going to talk about is from the original Keystone Pipeline in southern Alberta. And so this project effectively preserved populations of slender mouse-eared cress, which is actually a federally listed species. And the populations, I guess, as a stipulation for the project's approval, these populations were monitored over the course of 10 years to determine if the population's distance from the pipeline disturbance impacted the population's survival. So on the left here, these are some individuals of slender mouse-eared cress. And then on the right, we can see the spatial distribution of these plants relative to the right-of-way. And you'll notice that some plants are quite a bit closer to the disturbance, and then some are further away, which gives a really good set of treatments that the researchers were able to look at. And so perhaps rather surprisingly, by the end of the 10-year monitoring window, the number of individual plants had drastically increased. And there was also no significant difference between populations that were closer and further away of the pipeline. The fluctuations in both the fitness and number of individuals seem to be much more correlated with climatic conditions rather than their proximity to the disturbance. And the reason that by the end there were more than when the initial surveys happened are probably because of slender mouse-eared cress's rather cryptic life history. It exists within the same population as annual, biennial, and also short-lived perennial forms. So this allows the population to drastically increase under favorable climatic conditions. And so this sounds like a good news story, right? All the rare plants, they survived and they thrived. But however, I'd like to argue that this is maybe not the case. And so the reason for that is that the federal recommendation for industrial disturbance in relation to SARA-listed species is to have a 300-meter buffer between rare plant populations and the industrial disturbance. And this example really illustrates that a 300-meter buffer distance is potentially not necessary. And I'm going to add the caveat of this was a dryland system. Things may behave very differently up north or in a wetland system. And there was really low perennial weed load. The first year there were a decent amount of annual weeds, but the management activities that the operator conducted was sufficient to remove those in following years. And so the disconnect between, I guess, this example, this study, and I guess the suggestions from Sarah present two contrasting issues. So number one, if we assert that development and resource extraction must occur, then the best management practices recommended by regulators should be operationally feasible and ecologically necessary. Operators would probably be less likely to play ball if they, I guess, see that the regulations maybe aren't necessarily necessary. And two, a buffer distance, like as a just a concept, fails to account for population movement. As you can see from this image, there's quite a large spatial distribution across the landscape. And it also fails to account for cumulative effects. And sort of going back to my original question, if rare plants really are this sensitive, and we assert that their protection is important, why is development occurring in the first place in any proximity to them? These are the references for the studies I cited. Another one of my favorite herb plants, scent bottle, lovely one in our northern forests. Any questions specifically for me? I'll be available for questions with the rest of the grad students in just a little bit. But yeah, if you have anything for me, definitely add that to the chat. Thank you.
Thank you so much, Beckett. I'm the only one you can see, so I will clap. While we give folks a second to pop in their questions, again, there will be a Q&A at the end. But one question I had is, this study found that 300 meters wasn't maybe necessary for the slender
mouse-eared cress.
Mouse-eared cress. Do we need to assess every species separately, or can we make sweeping assumptions, or does every species need to be assessed on its own to see if it follows a similar pattern?
Really good question, Valerie. So I'd say yes and no. So yes, in that, like, these species are incredibly complicated in terms of like their relation to their environment. So, but then also no, in that there are species that are adapted to disturbance and there are species that are not. So for example, a lot of the pipeline development in northern Alberta is taking place along existing linear disturbances, such as like seismic lines. And in a lot of the rare plant surveys, like I guess in the pre-disturbance rare plant surveys, they're finding species that are really adapted to both like forest edge and forest openings that I guess are the reason that they're on the site initially is because they're relatively disturbance adapted. So for those ones, maybe that sort of disturbance might actually facilitate them. But for some really sensitive wetland species, they're probably not going to be adapted to this disturbance, and more care should be taken.
Okay, thank you. Heather's question is, do you expect further invasion of the pipeline by invasive species into the future, or is this a particularly careful and proactive restoration project?
I'd say that there was quite a bit of, I guess, care taken, given the operator's desire to build like Keystone XL. So there was quite a bit of like long-term monitoring that was, I guess, added on their certification. That being said, I believe that development is always going to bring invasive species in. Like it's impossible to separate that. Like this is a construction site ultimately. There's a lot of coming and going with like personal vehicles, equipment. There's just going to be weeds that are going to enter the site, and especially like in longer term, on a longer term scale, I do expect more weed species to be facilitated by that disturbance. But I think they also did a really good job in this example, to their credit.
Wonderful. Thank you, Heather, for that question. Andrew's question is, did the monitoring for slender mouse-eared cress consider the more intensive post-construction monitoring lead to the finding more individuals? Oh, the question is in the chat. Let me read that again, sorry. Did the monitoring for slender mouse-ear cress consider that the more intensive post-construction monitoring lead to finding more individuals, i.e. more time may have been spent on the ground post-construction versus pre? So we spent more time, we found more because we looked harder, essentially?
Yeah, I don't think it addressed it specifically. However, the population trend actually, or I guess across the 10-year post construction monitoring window, there was initially a bit of a dip, again, probably related to weather. And it actually took, I guess, about 7 years for that really like extreme growth to occur. So really, yeah, really just the last 3 years that there was up to like 1,000 individuals at these sites where there was like 20 kind of post-construction and then approximately that in the years following. So they didn't specifically account for that, and oh wow, that's such a huge issue and a huge can of worms. Like what comes to mind is like how like S rankings, like conservation rankings, like are assessed. Like, are there, if a species, there's a lot of the species that I've worked with, they actually sort of have since been like downgraded or indicating that they are less rare. But are they really less rare, or are we just finding more of them because we're like cutting more and more into their habitat? I think it's probably more of the latter, and that creates a real issue. If we think things are getting less rare, but in really their habitats are just being more and more impacted.
Wonderful. Thank you, Andrew, for that question. And thank you, Beckett. That was a wonderful presentation. We will see you in a few minutes for the Q&A at the end. So if you think of another question for Beckett, pop it in the chat. And I'm now going to invite Na on screen to share your presentation and to talk about your research.
Thanks, Valerie. Can you see my screen?
We can see your screen.
Okay. Hi, everybody. My name is Chen. So I'm currently a master student in land reclamation at the University of Alberta, and I obtained my bachelor in environmental and conservation sciences also at the University of Alberta. I'm from Zhejiang, China, which is approximately here. Yeah, it's very close to Shanghai. So I'm going to talk about the use of Sphagnum as a biomonitor in the Athabasca Bituminous sands region. So we know that the bituminous sands industry in Alberta has dramatic impacts on the economy of the province, but with the increasing extent of the industry, there are also growing environmental concerns regarding tree salmon contamination to the surrounding ecosystems by the industry. And previous studies have found that the total deposition of tree salmons increased with distance towards the industry. So here we are wondering, how is the reactivity of these tree salmons? So the aerosols that are emitted to the environment can be divided into coarse and fine aerosols. The coarse aerosols are generated by mechanical processes such as mining, quarrying, road construction, and wind erosion. And they are relatively large, typically in a diameter of 10 to 100 microns, and are insoluble, mostly in the forms of silicates and luminosilicates, while the fine aerosols are generated by high-temperature processes such as burning of coal and fossil fuels and smelting of metallic ores. They are typically in a diameter of 0.1 to 1 micron, and they can be easily dissolved in diluted acids, as they are mostly in the forms of oxides and hydroxides. So here we have determined the tree salmons in box Sphagnum, which represents the total deposition of atmospheric tree salmons and includes both the coarse and the fine aerosols. We also determined the tree salmons in the acid-soluble ash of the moss, which represents the fine aerosols. So why do we use the sphagnum moss? These mosses grow in ring-fed onboard trophic box, which means they receive their nutrients solely from the atmosphere, and they have a large surface area to retain atmospheric trace elements either physically on leaf surface or chemically to the leaf cells by ion exchange or chelation with functional groups. The absence of cuticles on their leaves enables the ions retained on leaf surface have direct access to the exchange sites in the cell wall, and the high cation exchange capacity and the large density of negative surface charge gives them a large number of binding sites per unit mass. So taking lead as an example, we have found that when going towards the industry, the total concentration of lead increased significantly, while its acid soluble concentration increased slightly. Both concentrations correlate significantly with the atrium, which is a conservative rainfall element and can be used as an indicator of mineral dust deposition, so that this indicates that the increase in total concentration of lead is largely contributed by the mineral dust input. And so if we look at the acid soluble, the proportion of acid soluble concentrations to total concentration, we find that the acid soluble proportion is actually the highest at the reference site here, while the majority of lead in the industrial sites is insoluble, which means low bioavailability. So yes, the total concentration of trace elements increased with distance towards industry, but the reactivity of these trace elements is pretty low. So our study highlights the importance to determine the chemical reactivity of the trace elements when evaluating their associated health risks to the surrounding ecosystems. And thank you for your attention.
Thank you so much, Na. I love seeing other parts of nature being used to help monitor nature. So if you have any questions for Na, pop them in the chat or the Q&A, either one. But my first question is related to your insoluble and your soluble fractions of those aerosols. What's the major risk when we're thinking about the coarse fraction, those insoluble metals? And then what's the risk of the more soluble ones for humans, for nature? What are the risks of those aerosols?
The coarse aerosols, they are quite of low risks as they are mostly insoluble, like ambient pH and ambient conditions. They are obviously insoluble as they are in the forms of silicates and aluminosilicates. While the fine aerosols at ambient pH, like for example, in the bog, the pH is 4. These can be dissolved, and the potentially toxic elements it contained can be released, so it will become harmful to the living organisms.
Okay, thank you. And the next question we have from Heather is it the in situ moss that is sampled, or are you putting out moss and then collecting it for sampling?
We collected the in situ mosses, we use a passive method. We collected mosses in those areas, in the regional areas where it is grown, and then analyze the elements in it.
Okay, that leads really nicely to my next question. And it sounds like sphagnum moss is a great material to use as a bioindicator. What other species of plants can we use in areas where maybe sphagnum moss isn't located? What other species are good? And if other species, not specifically, what characteristics are we looking for a good bioindicator?
Yeah, so our study focuses on the atmospheric deposition. So for atmospheric deposition, we have to make sure that the Mars and there are very limited limited imports from like groundwater there. So the sphagnum moss growing on tropic bogs receive nutrients only from the air. So there's very limited inputs from the groundwater, so we can say the nutrients is only from the air and all the elements also.
Wonderful. Well, thank you so much, Na. Again, Na will be around in a couple minutes, so you have time to think of all of your questions. But I'm going to get you to stop sharing your screen, and I'm going to bring up Kiah to share your work. We can see your slides.
Perfect. All right, so hello everyone, I'm Kiah, and a bit about me is I completed my undergrad at the U of A, where I obtained a Bachelor of Science in Environmental and Conservation Sciences with a major in land reclamation. Currently, I'm a Master's of Science student in land reclamation and remediation at the U of A, supervised by Dr. Robert Grant. And for my project, I'm using computer modeling to study how different management practices affect fertilizer use efficiency. So today I'm going to be talking about modeling nitrogen release patterns to increase fertilizer use efficiency in southern Alberta. Did you know that up to 70% of applied nitrogen fertilizer can be lost to the environment, resulting in not only economic losses, but also nitrogen polluting our air and waterways? Nitrogen can be lost as nitrous oxide emissions, which is a potent greenhouse gas, or leach to groundwater affecting water quality. Fertilizer use efficiency is a measure of how much fertilizer is taken up by the crop compared to how much is applied. And by increasing fertilizer use efficiency, we can decrease nitrogen losses. One way to potentially increase fertilizer use efficiency is to replace conventional urea fertilizer with polymer-coated urea, which is a controlled release fertilizer. Unlike conventional urea, polymer-coated urea has a polymer coating, which allows for nitrogen in the form of urea to be more gradually released. Water must diffuse through the polymer coating, dissolve the urea in the granule, which must then diffuse out of the polymer coating. This gradual release could result in a better synchronization between nitrogen available in the soil and crop nitrogen uptake, which could increase fertilizer use efficiency. However, there are many factors which influence nitrogen release, such as different environmental conditions and management practices. So how do we determine if polymer-coated urea can increase fertilizer use efficiency in southern Alberta? We could do field experiments, but they may not capture the variability of different conditions, and they can be time-consuming and costly. Instead, computer models that can accurately represent real-world conditions, such as EcoSys, could be used to determine all nitrogen inputs, uptake, and losses. But before we start modeling conditions in the field, we need to be able to accurately model the nitrogen release patterns, which is the amount and the timing of nitrogen release from the fertilizer. This is because the nitrogen release patterns will determine when and how much nitrogen is available to the crops and will influence fertilizer use efficiency. To determine if we could accurately model nitrogen release patterns in EcoSys, I modeled a laboratory experiment by inputting the soil moisture, temperature, and soil properties used in the laboratory experiment into the model to compare modeled versus measured nitrogen release patterns of urea and polymer-coated urea. The results are nitrogen release as a percent of nitrogen applied on the y-axis for polymer-coated urea in the red and urea in the blue, for modeled results, which are the lines, and measured results, which are the points. The day of the experiment is shown on the x-axis. For every 7 days, the temperature was increased 5 degrees from 0 to 40 degrees as marked on the graph. And the experiment was carried out at 2 moisture levels, 50% field capacity as shown on the left graph and 75% field capacity on the right. The 75% field capacity had a higher rate of nitrogen release due to the higher soil moisture, as can be seen by nitrogen release approaching 100%, but overall temperature appears to have a greater impact on nitrogen release. Compared to urea, polymer-coated urea has an initial delay in nitrogen release. For measured nitrogen release, we can see the delay between these points. And for modeled, we can see that the delay lasts about a week longer for polymer-coated urea as compared to urea. And this delay is due to that polymer coating. When crops are first planted, nitrogen uptake is low. Therefore, a delay in nitrogen release could minimize nitrogen losses and allow for more nitrogen to be available later in the growing season when the crop needs it more. This could increase nitrogen uptake and increase fertilizer use efficiency. Now that we can accurately model nitrogen release, we can use these results to model nitrogen release, uptake, and losses under field conditions for different environmental and management practices in southern Alberta to determine if or under what conditions polymer-coated urea could increase fertilizer use efficiency. These results can in turn be used to provide information on effective fertilizer management strategies for policymakers and producers. Thank you.
Thank you so much, Kiah. Again, I'm the only one you can see, so great job. Again, everyone pop your questions in the chat. We have got some time for a Q&A, but my first question is, we can see in that graph that you showed that while temperature does play a different role, having more moisture did release more nitrogen. Does that raise concerns with using polymer-coated urea in areas experiencing drought conditions? Or is that a challenge whether you're using polymer-coated or not when it comes to your fertilizer?
Yeah, so the literature shows that under dry conditions, using like a polymer-coated urea may not provide those benefits because nitrogen release is going to be slowed anyways. So there may not be those like increased nitrogen uptake or decreased nitrogen losses when under dry conditions, you already have such a minimal, like those risks are so minimal to begin with. So,
So does that really play a role when you think of your research in relation to climate change in expanding? How does climate change impact your research?
Yes, so since I'm looking in southern Alberta, it's pretty dryland condition, which is why there's been such variable results so far, and if polymer-coated urea can actually provide these benefits. But with climate change, actually, there probably will be increased precipitation, which means that there may be an increased need to actually use polymer-coated urea because it could reduce nitrogen losses when we have those increased precipitation events. So there could be increased effectiveness with it with climate change, but obviously that will not be, we'd rather not have those losses to begin with, but if we do, this could be a potential solution.
To dealing with multiple things. Heather wants to know, is the coated urea currently commercially available? If not, would there be any challenges in making it more widely available if your research is finding that it's much more environmentally friendly?
Yes, so recently polymer-coated urea has become commercially available, but it's more expensive than just conventional urea. So it's about 15 to 30% more expensive. So unless you're getting that increased nitrogen uptake, which could lead to increased yields, or you're decreasing nitrogen losses, and producers are compensated for that financially, there may not be an incentive to use it. And because it's more expensive, it's not widely used currently. So
thank you so much. That answered another one of my questions. And thank you, Heather, for that question. I am going to bring everybody back. Beckett, Kiah, you're already here, so just don't leave. So we have all of our speakers here. If you can join us when you get a chance. So the floor is open to ask anyone any question that you have. There is a question in the Q&A for Na. Dorothy wants to know, Na, do I understand that the highly transmissible, that the transmissible soluble will be more harmful to animals and humans farther away? Oh, you are muted.
Yes, the fine aerosols, due to their relatively small size, they can be transported for thousands of kilometers away from their origin, so that, yes, it will be harmful.
Thank you so much. Beckett, I had a question. You were asking questions about should we be doing industrial disturbances near these rare plants? Are our current rules what they need to be? How do we bridge the gap between policy, industry, and restoration science? Right now, it seems like you're getting different answers from different sources. How do we bridge those differences?
Probably the best way to do it would be to get more scientists and science communicators actually like into I guess elected positions, but then also I guess just more folks that understand the science in government, because or I guess the example that Chen was talking about earlier with the Ministry of Highways Pollinator corridor. That I think it was even the Highways Ministry itself that was like spearheading that. So I think the more engagement and with the science that is happening with regulators, probably the better. Also, I guess communicating, like science communication to the capacity of just having a more educated public that are going to maybe demand these changes, I think would be really beneficial.
Speaking to my soul, as a science communicator, all of that. Thank you so much. Kiah, tossing that question to you in slightly a different way, you were talking about how we likely won't see a large immediate uptake of this coated urea because of the higher costs. Do you see a role in that science communication between, again, scientists and farmers to try and bridge that gap?
Yes, so currently the policy is there's a policy for the nitrous oxide emission protocol. And in that policy, if farmers switch to using polymer coated urea, they can get carbon credits. So there is that, but at the same time, because it's so variable, if this fertilizer can actually provide those environmental benefits, then we really need to be looking at the science if it does provide those benefits, because if it doesn't, then why are we providing carbon credit? So it's almost the opposite. Like the policy is trying to promote reducing nitrous oxide emissions, but if we're consistently not seeing that, then should it still be in that policy?
Absolutely. We need to know before we push for people to buy it. We have to know it is actually valuable for these reasons. It's a really good point. And just in case you missed it, there is a comment in the chat about a potential use in riparian areas to reduce nitrogen runoff into those more at-risk areas.
I think that's very interesting because right now polymer coated urea, it's just looked at in an agricultural perspective, but it could be applied in other situations like in land reclamation or in riparian areas. So that would be very interesting to see research move towards that as well.
Again, I feel like every time we do one of these talks, it's just 1,000 more research questions that we've thought of. So you guys can never leave me. You have to stay in LRIGS forever and just answer all these questions. It'll be great. The next question is for you. Your research found patterns with increasing how close you were to industry. You were getting more aerosols on your moss. How do you address the challenge of multiple disturbances that are from different directions, different distances from each other? How do you address that in your research?
Well, we have normalized the trace element concentrations to the concentration of lithophile elements. So like if there is the source is only dust particle, then the trace element concentration will be proportional to the concentration of the conservative list of our element. And if there are additional sources of the element, then it will be disproportional. And if there are any stress on the plant and causing an higher or lower concentrations of the element, it should also be reflected, so we can detect that. Yeah, we have also created windrows diagrams for the region, so we can see the predominant wind directions, and you see where the concentration is higher, it's where the predominant winds blows.
So much science behind the science, for sure. Okay. So many comments about how great everything has been. There is a comment in the chat, Kiah. I don't know if you have anything to say regarding it, about polymer coating used on coated seeds to reduce dust and runoff losses. If you have anything to say regarding that comment.
I actually haven't heard of neonic coatings, but it's something I'm going to be looking into now. Thanks for that comment.
Thank you, Heather. So this will be our last couple questions. So if you've got them, pop them in the chat. For each of our speakers, I just want to ask you, Kiah, you've mentioned this briefly, but what's next in your research? What's the next question that you're trying to answer, the next area that you're focusing on? Beckett, we'll start with you.
Becoming gainfully employed is what I'm focusing on next. I guess, yeah, as far as my research program, not a huge amount, but I guess in what I'm up to in terms of like native plant activities, I think I'm pretty close to potentially finding a unknown to potentially anybody else historical site for common ironweed, fasciculate ironweed in Saskatchewan. So it's currently extirpated. It might still exist though, because I think some of the information that's gone into previous survey work for it has been incorrect. So stay tuned for that. That's the most exciting thing I'm up to other than writing.
Hey, thank you, Beckett. Now, what about you?
I think for my study, further research might be needed for the acid insoluble ash fraction. So we have analyzed the acid soluble fraction, but we haven't analyzed the acid insoluble fraction. So if we analyze that, we could make sure that our previous studies it is consistent with our previous studies, and also probably like sequential extraction of the trace elements, so we can see from each step which elements can be released. And also further research is also required on the ultrafine clay minerals to see the elements they contain and the potential risks.
Wonderful. We'll just have to have you back in a few months to find out what's happening. Thank you so much. Kiah, I know you addressed this briefly, but what's your next big focus?
My next big focus is modeling under field conditions. So I want to look at how different fertilizer types and rates affects crop yields and crop quality, as well as nitrogen losses. So nitrous oxide emissions, nitrogen leaching, ammonia volatilization.
Wonderful. Again, I cannot wait to hear more. So I would like to, on behalf of everyone here, give a huge round of applause to our three speakers. Thank you for preparing these 5-minute presentations. Literally the hardest type of presentation to prepare is when you don't have much time to share everything you want to. So thank you so much to our three speakers. You were all amazing. If you want to ask them any more questions, they will be around for a few minutes in the chat for you to ask some questions. Beckett will be here the whole time with me. to lead the next part of our session. But Na and Kiah, thank you so much for joining us today. It was so wonderful to learn everything that you're working on. So I am just going to share my screen again and make sure that everyone can see it. Okay. So we are now heading into a bit of a different kind of presentation than you may be expected. So we are going to introduce you to our land reclamation outreach program. And this is going to require some interaction. So we hope that you are ready. I am going to pop a link in the chat to a scorecard that you're going to need in this section. But just to give you a bit of background, our goal with our LRIGS outreach program is to share land reclamation with the community, really build up a science literacy around land reclamation. Often we still meet people and we say we work in land reclamation, they say, what is that? So our goal is to really build up that literacy around the topic and build connections between communities and researchers so that we can all learn from each other. So part of the LRIGS training for our students is training for outreach skills, a variety of communication skills. And since December 2020, we have been involved in over 50 outreach events, particularly over 40 sessions surrounding our land reclamation game. So just over 2 years ago, the members of LRIGS got together and developed a Dungeons and Dragons style game to teach students about land reclamation. And we have done this game with everyone from kind of grade 4 to college and university students, community groups, and we have adapted versions for kind of kindergarten to grade 3. So we are inviting you to play along with us today. You are going to know a lot of this content, but the goal of this game is to make you think like a land reclamation practitioner. So you are going to have to think about the different steps of land reclamation and how you make your decisions. So Beckett and I are going to be guiding you through this game. We are going to encourage you to use the chat box. Please use it so that we know what you're selecting. We can't see your faces, so if you can engage with us in the chat box, that would be amazing. So the goal of this game is to successfully reclaim a site on time, on budget, while keeping your stakeholders happy. You are going to need a dice or a random number generator. If you have a phone, just Google a digital dice or a digital random number generator. You're going to need 6 things, 6 pencils, 6 Post-its, 6 anything, 6 coffee cups. You just need 6 somethings and your scorecard, which is linked in the chat. So we'll give you a couple minutes to grab those supplies. And if you can give me a yes, I have them in the chat so that we know that people are good to go. And while you're grabbing those supplies, I am just going to show you a couple other parts of the game. So these are what our cards look like. Each one will describe a method of reclamation at a particular point. So in this part, we are at the remediation stage, and we are learning about natural attenuation. So allowing the soil to decontaminate naturally over time with the microorganisms in it. There is a set cost and speed associated with each item and an effectiveness. And that effectiveness is related to how likely it is to succeed. The more effective means the fewer times you're going to have to roll, and the cheaper it is probably going to be. So it is something to think about. And then you also have your stakeholder opinion, and you have 3 options. You have happy, moderate, and angry. So, and you should have your scorecard. This is what it looks like. You're going to start with a certain number of points. You're going to lose points throughout the game. And you want to end with points at the end. So just to touch base on those stakeholders a little bit more, you're going to put, of those 6 items, You're going to put 3 of them in front of you right now. Those represent the stakeholders that already support your project. You've already convinced them. They think your project is a really good idea. Yay. The other 3 stakeholders you're going to put off to the side. Those represent the communities, the stakeholders that you still need to convince. Throughout the game, you can lose the stakeholders that are in front of you, and you can gain stakeholders that are beside you. You have to have a stakeholder left by the end of the game. There's a trick though. If you have to roll multiple times in a round because you don't succeed the first time, you can gain or lose multiple stakeholders. So if you pick an option that makes stakeholders angry and you have to roll 3 times, you will lose all 3 stakeholders. Just keep that in mind. And then you will have to complete each step of reclamation. So I see that a few people are ready to go. So we are going to jump right in. So step 1 is to select and end land use. Reclamation is always done based on what we're going to do with the land after it has been disturbed and reclaimed. So we are considering if we are going to be making a forest, a park, a wetland, a national park, a natural area, community garden, whatever it is, that influences our reclamation plans. And that is always going to be influenced by our stakeholders, our communities. So here are your 3 options. This gives you your starting points. So you have an option that has little time and lots of money, lots of time and little money, and right in the middle. And you are going to write that number in the top line of your scorecard. So I picked the middle one. So we're going to bring it back and then you're going to select. And once you've selected, pop in the chat which one you selected and why. Beckett, which one would you pick?
I went with the 90 and 90. I think that gives us a good spread if we have to make some tough decisions, especially if some of our reclamation strategies aren't working.
Absolutely. That is a very good choice. And I can see in the chat that some people have to go. I will pop the email address for our program in the chat. So if you do want to hear more about the game, I can send you a copy of it later. Or if you want to connect, that is the best email address to connect to. Okay. For everyone who can stay and keep playing, what are you selecting? We have seen people win in every option. Oh, Heather's picking lots of time and not a lot of money. Because you're patient, I love that reasoning. It's a great reasoning. Joe's picking the 3rd option, really balancing it out. Yeah, those are great reasons. And when we do this with school kids, it is a great way for them to be thinking about long-term planning, budgeting. It is a really valuable tool for teachers to use. Sarah wants immediate results, cautious. Okay, we are all over the place. So we'll see what is most effective in this game. All right, we are going to head to the next round.
Okie dokes. So our first, I guess, second choice we need to make is our remediation technique. And so remediation is the process of removing contaminants from the environment, usually the soil or the groundwater. So in this case, this is going to be a hydrocarbon spill. So we're going to have really nasty things like benzene, like really like heavy crude oil and gas products. Okay, so we want to consider the budget and the timeline as well as the likelihood of success. So one thing that is important to mention is that if you're not successful, you can try the same method again, or you can select a different method. And as Valerie mentioned, you need to consider the stakeholder response. If you If you try something 3 times and it doesn't work 3 times, and it's like maybe a little bit less optically savory, you're going to lose 3 stakeholders. Okay, so the first option you have is natural attenuation. Basically utilizing the natural ability of indigenous microorganisms to eat up those tasty hydrocarbons. All the other options are biopiling. So gonna take a dozer, excavator, scoop up all that soil, take it to a company, and they're gonna put it in windrows, often with irrigation and sometimes even the bubble oxygen through it. And this is really useful because it's really easy to monitor, because you don't have to go to the field because it's already at your site. There's thermal desorption, which I believe this is usually an in situ process where they're putting heating probes into the soil. The logic being most of the nasty hydrocarbons are volatile, so they're evaporating even under the natural conditions. They're just doing it relatively slowly. But if we can increase that evaporation through heating, that's going to be really helpful. Our last one, dig and dump. You're picking it up, putting it in a landfill, and then getting new soil from somewhere else. Areas that I've heard of consultants getting new soil is they'll ask like a developer who's like digging out like basements for a housing development, like, hey, can I have some of your soil? Like, we'll take it away from you. Or another way people do this is they'll offer to dig a dugout on another part of a landowner's property, and then they'll put that soil like on the well site. Again, note the stakeholders. The ones that's going to lose you stakeholders is dig and dump, biopiling, and thermal desorption. Those are some like high tech methods. People are going to really like that. And then natural attenuation, we're just kind of letting nature take its course, which, I mean, some people might think that's a bad thing, but probably some people think that's a good thing. So it kind of balances out. So here's just an example on our scorecard. So we chose biopiling. So we rolled Valerie, could you explain what the actual roles were on this?
So we rolled a 3 our first time, which meant we did not succeed. So we had to pay 90 minus 15 for time and cost, but we did get an extra stakeholder. So we now have 4 in front of us. We rolled a second time, we got a 5. That was successful, which meant we still had to pay time and money, leaving us with 60 cost and 60 time points, but we got another stakeholder. So we have 5 stakeholders in front of us, and we are left with 60 time and 60 cost. So think about, for everyone that picked the low time or the low cost, is the method that you've selected going to work when you need it to? So we're going to bring back the scorecards. So you get a stakeholder if you select an option that makes stakeholders happy. So if you pick biopiling or you pick thermal desorption, every time you roll, you get a new stakeholder. So if you have to roll 3 times for biopiling, all 3 stakeholders that were living off to the side are now going to be in front of you, and you have 6. From a game development side, stakeholders were one of the biggest challenges for us, weren't they, Beckett? Figuring out how do we incorporate that stakeholder opinion. We really want people thinking about that when they're learning about reclamation, but finding a straightforward way to do it in a game, so challenging. Congratulations, Sarah, success with the first roll. What did you pick and why? So feel free to pop it in. So I picked biopiling. Beckett, what would you pick?
I went with thermal desorption because that sounds pretty high tech.
Pretty high tech.
I like shiny things.
It is fun. Natural attenuation, hanging on to those stakeholders. Congrats on getting a success on your first roll with natural attenuation. That's a tough one to succeed with. So we have played this one time we played this and someone had to roll 10 times in their first round. They did not have very much time and money left at the end of the game.
Something to note, just make sure that you're also recording what choice you made, as well as I guess tabulating your score, because that your choices might come back to bite you or help you in a lightning round at the end.
Absolutely. Congrats, Joe, on that lucky 6 for biopiling. And Heather, we got some biopiling success here. Okay. Unless I get some calls to pause, we're going to go to the next round. Anyone need more time? We good? Oh no, 3 times. Okay, heading to step number 3. Now we have to think about our soil reclamation, specifically our amendment selection. So when we think about our soil, we know that it can take thousands of years to build up naturally. Nature knows what it's doing, but it can often take a very long time, particularly in many locations that we work in. Where I work in northern Canada, in the Northwest Territories, soil develops extremely slowly. So it is a non-renewable resource. Therefore, we have to find ways to save it and protect it. Therefore, in disturbances, soil is often stockpiled. It is scraped away and piled up. However, if you leave that soil piled up for years and years, it is not especially healthy anymore. The organic material has broken down, so it's very mineral heavy and not very organic. Many of those microorganisms have died. There's a lack of oxygen deep within the pile. Most of the seed bank has died. So that soil stockpile isn't necessarily the healthiest anymore. The way we describe it to kids is if you piled up your dirty laundry for a year, would you want to wear any of those clothes anymore? And then I beg them to say no. So that stockpile isn't necessarily healthy. So we might need to add a material, an amendment to it to make it healthy again. So in this case, you are going to be amending a soil stockpile. I do just want to note that in some cases, you may not have a soil stockpile to amend. Where I worked in the Northwest Territories, there was no soil. We built the mine on top of the soil because we couldn't disturb it due to the permafrost. So they laid gravel on the surface of the soil, and then that is the new surface that we have to reclaim on because we can't remove that gravel because it will disturb the permafrost. So we had to take materials like gravel, sand, human sewage, mix them together in different ways, different amounts, and figure out how do we get plants to grow. So again, think about your budget, your timeline, your stakeholders, and your effectiveness. And here are your 4 options. You've got manure, a great material for us to use. It has a cost associated with it, and then an extra cost because we need to do lab testing. Anytime we're using kind of the manure, the human sewage, we do some lab testing to make sure that it is deemed safe. Fertilizer, that inorganic material, really going back to Kiah's research here, a lot more expensive than manure, but a lot quicker as well. On-site salvage material, the gold star of amendments. This is things like salvage soil, wetland material such as peat or LFH mixed in with various other components to get that ideal organic material. This will add seeds and invertebrates, microorganisms to your soil. So this, while expensive and often slow, will likely work. It has a very high effectiveness. And then finally, you can do nothing. That is always an option. It is free. However, it is very slow and it doesn't make your stakeholders happy. So what will you pick? And will it work? So I think, Beckett, I have to go with on-site salvage material. I know it costs a lot and is slow, but it's probably going to work and it is the best.
You got to be careful with that on-site salvage material, though. If you leave it in stockpiles for too long, oftentimes the temperatures can get high enough on the inside that those seeds and soil invertebrates can basically be killed. So you really have a max like a year, if even that, in stockpiles. And if you're ever telling someone in a dozer how to do this, you want the top 10 centimeters. That's where all the good stuff is. That's what I went with too.
Absolutely. And really, direct placement is best. If you can literally take it from one site and bring it to another, direct placement is the best way to go. Sarah picked fertilizer. You got to conserve those speed points. Nice, successful in the first round. We love success. It is, as we get into these rounds, it starts to get a little more dicey. You're starting to run out of points on things. So, oh no, Heather picked nothing because they're too broke for anything else. I'm so sorry. Another Heather picked manure. Success on the first round. Yeah, tight budget. Is reclamation expensive? Yeah, a little expensive. Absolutely. Amazing selections. Thank you all for sharing. We really appreciate you all getting engaged. It makes it so much more fun for Beckett and I to have you to chat with as we're going through. Oh no, manure, but failed first, so kind of got expensive. Yes, that is the challenge. Okay, we'll give you like another 30 seconds and then we will head to the final round where you get to make any choices. After that, it is in the hands of the reclamation fates and you're going to want to cross your fingers. Gets a little risky at that point. Okay, Beckett, you good?
Okie doke. So we're on the revegetation step. Revegetation, I guess putting green stuff back on top of the disturbance. So sometimes called restoration if it's using native species, but revegetation would probably be more appropriate if you're using perhaps forage grasses to put on the site. I think up until maybe the 90s, the requirement for revegetation was generally just to get something growing on it. So in a lot of legacy well sites, I guess across the Prairie provinces, they're nice and green and growing, and you can see them from space because they're all seeded to crested wheatgrass. Could you just go to the next slide so we can see the options? Okay, yeah, consider your budget and timeline, as well as the likelihood of success. I imagine some people might be down to the wire at this point, but there are, and remember, there's some opportunities to gain extra points, but there's mostly opportunities to lose them. So try to conserve as many points as possible. So starting off with the option of native plants, this would be I guess the school of thought of ecological restoration. So we're putting ostensibly what was there before back on the site. People are really going to love that, as I know how enthusiastic everyone here is about native plants. We can pick non-native plants. This would be in a case where budget is potentially really tight. Like I was pricing out the difference between native grasses and forage grasses, and like native grasses are like the cheapest I could find was like $11 a pound, up to like hundreds of dollars a pound, whereas most forage grasses are pretty cheap, like sort of in the $1 to $5 a pound range. And then mixed planting, the presentation from the folks at Xerces really highlighted how this can be useful, especially like in an agronomic landscape. And nothing. Something that's important to consider is that if you plant nothing, what's going to show up? So this part of the world will probably end up with a lot of Canada thistle or other undesirables. Heather says, I'm broke though. I need a free option to let invasives come in. And Chet's going for broke with the native species. That's perfect. I've been lucky, so I'm going to go with the native plants. But this is the first time I've played the game and not lost all my money on the first round. So feeling lucky today.
Oh, it's true. I love the discussion that's happening. All I could afford was non-native needing a bake sale. Even though non-native would save points, I can't ethically do it. I feel like you will all appreciate this story. We were with a group of grade 5 students, or Girl Guides, so grade 4 to grade 6, and they were at this point of the game and they were like, if we pick native plants, we're going to lose. But native plants are the best for the environment and they are most likely to succeed. So we might have to pay more now, but we won't have to pay as much in the future. And I was like, oh, that is some amazing reasoning skills that these Girl Guides had. We got some people that are a little broke, that are succeeding. Does anyone have time and money left? Is anyone succeeding yet? Oh, Beckett, well done. Okay, Sarah has some time and money left. Okay, we'll give you about another 30 seconds, but while we do that, I need everyone to type a number between 1 and 24 in the chat. The first 3 numbers will be the numbers we use. 17, 2, another 17. I need one more number. 20, between 1 and 24. 22. Okay, 17, 2, and 22. Those represent the things that we can't control. So we are heading into our last round called Risk It All. There are so many things that can impact our reclamation projects, both natural and anthropogenic, that we have no control over. So we are going to see what happens to your project. So you have a spot in your scorecard for risk card 1, 2, and 3. On each of these cards may be positive or negative. So fingers crossed. Card number 2 is a negative. People were skiing on avalanche terrain and caused an avalanche that damaged the road that leads to your site. Subtract 5 cost and 5 time. I gotta say, that's not the worst negative card you can get. There are some that are like minus 20 points. So -5 and -5, not too bad. Okay. Next card is card 17. Also a negative. An unusual drought caused by the changing climate kills half of your vegetation. Subtract 15 cost and 5 time. I think Heather's emoji in the chat is how we are all feeling. Okay, last card is card 22. And here we go. Also a negative. Too bad, the tree planters you hired were freshmen and many of your plants die a year after planting. -10 time and -10 cost. Yes, Joe, oh no. That was not an effective risk round. That was a lot of negatives. So you had -15 cost, -5 time for card 17, and -10 cost and -10 time for card 22. Beckett, do you have any money left still?
No, I'm dead broke.
So the question is, were you successful? Did you have any time? Did you have any money left? Yes, can we lend people some money? Does anyone have any money to lend Chet? I don't know if anyone has any money left. But also, Sarah has cost but no time left, but still stakeholders. Good. So we have to balance all of those different parts, our finances, our timeline, our stakeholders. Oh, nice, Luke. You have 6 happy stakeholders, and maybe that extra time you have left can balance out your costs that you went a bit over budget on. So we really want to thank you for playing along. The stakeholders are just worth like peace in your heart and happiness. No financial value for you. I'm sorry. It will not balance out.
You do have to end the game with at least one, though. So
yes, if you had money left, but you had no stakeholders, you'd still lose. So you are definitely not losing because of stakeholders. So thank you for playing. We know it's a bit of a silly game, but it is an excellent tool that we have really found useful for teaching kids about land reclamation, about nature, and about what they can do. So thank you for playing along with us. If you want to know more, you can check out about the game and our program. You can check out the LRIGS website. You can contact us at lrigs@ualberta.ca. And we are here to answer any last questions that you have. But thank you again so much. And thank you, Beckett, for being an excellent co-host.
Thank you, Valerie. I thought we kept the banter positive in light of the massive risk failures that happened.
Yeah, it was pretty bad. That was a pretty bad risk part of the game. The last group I played with got all positive cards. I'm like, oh, so they jinxed you all. Yeah, Sarah's under budget, so a bit of extra time to carry out the project. Maybe one day we'll adapt the game so that if you have extra time, you can transfer that to budget. Or if you've got those stakeholders, I saw somebody earlier that said those stakeholders will volunteer on your project. So maybe that'll save you money at the end. An extra 5 points for each stakeholder, because maybe they will provide funding or volunteers. But thank you all so much. Chet, that is all for us. But if anyone does have any questions, we are here.
That was great. Thank you very much. Just so everybody can see how I scored, minus 30 cost points, 0 time points, so I broke even there, and all 6 stakeholders. I had to make the people happy. So I'm fine. I'd rather have 6 stakeholders happy than a bunch of money left over at the end. So yeah, went a little bit in the hole there.
Well, and sometimes you just have to pick the one that you feel ethically or morally responsible for. I have trouble picking nothing or dig and dump. I can never pick dig and dump.
Right. Yeah, I was the same. Yeah. Are there any more questions? Yeah, that was a lot of fun.
Well, we really appreciate you inviting us. Thank you, Beckett, for connecting us. But thank you for letting us share our game. It's a lot of fun. And for our amazing researchers, again, huge round of applause to them, because their work is really making a difference.
Yeah, and I think, with great minds like that, I worry less about our future when I see presentations like we've seen. So I think we're in good hands with the next generation for sure. Let's see. No questions, but just funny comments in chat. Heather says to Sarah, you need to spend it or the government will take it back. So yeah, spend it or use it or lose it, right? Yeah, so all right, well, thank you very much. If there are any other questions for any of the LRIGS folks or anybody that you think of after the fact, you can always email me. I've got their contact information. I can reach out to them for answers. That brings us to the end of our day. I think that was went quite quickly, even though it was very action-packed. Thank you for sticking with us to the end. Thank you to Dr. Miller and all of the LRIC's team. And yeah, it was just a fantastic day of presentations. I hope we can all use this as a jumping off point for different things. I know I'll be following up with Heather Facette for a potential field tour to some of the restoration sites at Grasslands. I will continue to talk to Katie Suek about Restoring 71 and how we can support that initiative. You know, obviously I'll be in touch with Beckett. He's on our board. So we've got a March board meeting coming up, and I hope to stay in touch with all of the folks at LRIGS and what they're doing, and see how we can find synergies between what we're doing and what they're doing. And really all of that, you know, hopefully Stephanie Frischie makes it up from the States this summer. And yeah, I mean, just all of these presentations will fit into what the NPSS is doing in the future at some point. So I hope you all found value in that. I thank you all for attending, for your donations. We raised quite a bit of money for our habitat conservation programs and education programs. I don't know what the dollar amount is yet because there were still a few donations coming in today. And then we'll add what we make out of the charitable auction onto that. And then all of that will go into some of our programs like the South of the Divide projects we've got going on, Rare Plants and Ranchers. So every dollar will go directly to action on the ground. None of it will go to administration or any other kind of frivolous thing. So thanks very much. Have a great day. And I hope to see all of you soon. Bye-bye.